Well, good morning and welcome to HV News' Future of HVAC Summit virtual version. Spread across 2 mornings, today and next Thursday, we are homing in on low carbon heating and IAQ, particularly in the age of COVID. Today, we are aiming to give you an insight into the key developments in low carbon heating technology and in the policies and strategies around it. In the space of a morning, we aim to take you from Hackett to hydrogen and from ground source to grid balancing. So grab your coffees and strap in. We're in the hands of the gods of Zoom and broadband today, so we ask you to bear with us if we do encounter any technical difficulties. Now, we can't put on an event like this without the support of our sponsors. So thanks to Residio and to Cancer Contracting, who you'll hear from today, and to Swagon and maybe others who you'll be hearing from next week. Now, during the talks, do feel free to use the question facility to pose your queries to the panelists. The advice is to keep the questions short, and if you have to use several sentences, don't press return until you're finished. We'll try and get through as many questions as we can on the day, but virtual events always bring more questions than the time available. So the promise is we will do our best to get them answered. So let's begin. We're delighted to have as our keynote speaker today, David Fries, Chief Executive of BESA, and a man as passionate about industry cultural change and about sustainability as he is about Tottenham. David.
Gareth Bale, that's all I'm going to say, Andrew, Gareth Bale. And there we are. Thank you very much. And good morning to everybody. So the first thing I wanted to say was good morning. What does the industry need? And the first thing I had to do was actually Google what a power talk was. So I did Google it, and the first thing that came up was that it's the group language of sociopaths. And as I've been a contractor for many years, I thought that probably sounds about right. The second thing that came up was that power talks' first trait is to have that they promote positive expectations. So I put on my power shirt, as you can see, only ironed the front, obviously, that's one of the advantages of Zoom, and I will try and exude power expectations or positive expectations today. So what does the industry need to do? Well, I'm going to start with the 3 big things that I think are going to influence the market in the next 10 years. First, COVID. And you might say, well, COVID, that'll be gone in no time at all. We'll have a vaccine and we'll go back to normal. Yet I don't believe that's true. In 1815, Mount Temora, a volcano in Indonesia, erupted. Bit of history, I guess. And it was the largest volcano eruption in 80,000 years, killed more people than any other volcanic eruption in the world. And there was enough pumice from that to cover the UK knee-deep in ash if we were to compare that. It didn't, but that's if you were looking for a comparison. But what it did do was cover the whole world in a veil of sulfurous dust that effectively cut out the sun. And 1816 was known as the year with no summer. There was an exceptionally harsh spring, no summer, and snow fell in June and July. In fact, it was orange snow, and people thought actually this is the end of the world. They didn't understand climatology, they didn't understand any of these things. And it's the time that Frankenstein was written, actually, because people were so concerned about this orange snow that fell out the sky in the summer. You can imagine that actually devastated the crops at that time. And at the time, Europe was not really in a very robust position. In 1815, they just finished the Battle of Waterloo, ended the Napoleonic Wars. And that had had huge impact on commerce at the time, particularly between England or Britain and the Central Europe. But throughout Europe, commerce was at an all-time low point because of the wars. Trade needed to be reintegrated, but before they got the chance to do that, this huge ecological crisis hit them. And because of the hunger, there was huge social unrest caused by that, not surprisingly. which ultimately led in England to the Peterloo massacre in 1819, a few years later. My point is that a single thing in a year didn't last just for a year. The UK, however, did much better than some other areas because we had a very powerful Royal Navy at the time and we could keep our supply routes open and we imported food. We did much better than mainland Europe, where epidemics of typhus, particularly hit Ireland as well, led to massive migration to America and to other areas of the world. And in China, it was a worldwide crisis. In China, the rice crop failed 3 years in a row. And when the farmers came back to farming at the end of that, they planted opium instead. What I'm doing is illustrating this as an example of an impact of a single world event, which is COVID in effect, which appears to be short-term, but actually leaves us with long-term impacts. Migration was a huge change, changed America, changed Europe. We ended up with drugs widespread in a way that we hadn't before. And the social unrest led to massive political change during that period. So COVID is going to disrupt us for far longer than I think we can imagine. And I'm not sure how, but it will have an impact on us. Yesterday, the chief scientific officer at the World Health Organization said that because of the lack of vaccines, social distancing is still going to be a concern late 2022. And we're not expecting tourism, for example, in the UK to return to normal until about 2023, 2024. And I talked about the impact of the Napoleonic Wars on trade. Well, what are we doing at the end of this year? Brexit, which is, I think everybody acknowledges, will disrupt trade in some way. And I'm not making any political point, but we have that to add to disruption. The second issue is Hackett and the impact of Grenfell. The tragedy at Grenfell should be the single biggest driver for change. And it's a disgrace that we've not yet dealt with the aftermath. And we still have people living in unsafe homes, some 3 million people living in unsafe homes, and also economically devastated by the fact they've got zero valuations on their properties. And I think that's an underestimate, 3 million. If you think back over the projects you've been involved in the last 10 years, and tell me that the passive fire protection was up to scratch, then I'd be surprised. So I think it's more than 3 million, and that will come out over a period of time. If you do nothing else after today, please subscribe to the BBC Sounds podcast on the Grenfell inquiry. Listen to the summaries. And if that doesn't change your opinion or make you recognize that we need to do something, we have a moral obligation to prevent that happening again, nothing will. Of course, the Draft Building Safety Act should ensure it does not, but I'm not really sure that enough people have got the message about the change that is coming. I think we can expect to have to evidence our competence and compliance at an individual level and at a company level, and that you must be able to account for everything you've designed, installed and maintained on site with proper records, a golden thread of information, not a collection of manufacturers' brochures and tender documents stuck into a file and handed over, or literally lobbed over the wall. And at BESA, what we've done is made our technical audit far more robust to make members ready for that change. We're making it more difficult for companies to join us. And that might seem counterintuitive to make it more difficult to join, but we think we need to show leadership in this area. And I believe that good companies have absolutely nothing to fear from this change, from a more robust system. It's the corner cutters, the chancers, who have something to fear. You could argue that the PQQ systems do this already. Let's face it, it costs the industry billions in filling out forms. But currently, I don't think PQQ systems really fit the bill. The new Build UK PQQ system, which we fully support and we think is a good thing, asks nearly 300 questions, but not a single question that says, can you do the job? Can you strangle pipework into a plant room? Can you design and install a VRV system? Can you install ductwork properly? So our competence assessment standard now focuses on the can you do the job? If you have a construction line gold or similar, or the Build UK PQQ, it's a given that you've passed that bit and we won't re-audit. We will just ask you, can you do the job? And we're doing this because it's a fact that we all understand that the fact you can't do a job has never stopped you winning a job in our industry. And that really, really has to stop. And you have to hope that the new Building Safety Bill will deliver on the promise that the Hackett report said, that clients will understand their responsibilities and will feel that responsibility. At this point, you're probably asking yourself or thinking, isn't this prior talk about low carbon heat? And didn't he say he was going to promote positive expectations? And you may have a point. But if I'm going to argue that my third key issue, climate crisis, which drives the low carbon heat agenda, will not get a look in until we deal with the other stuff. And why is that? And a bit more history. And this is William Hazlitt, a Victorian philosopher, who said that our future self does not exist. And what he meant by that is that we don't deal with future stuff until it's right in our face. The reason I didn't iron this power shirt until this morning was that yesterday's David said that today's David would deal with it. And I'm cursing yesterday's David, but I didn't do it. And that's the reason that we have a social care crisis. That's the reason we have a pensions crisis. And successive governments have failed to grasp this on climate crisis too, because we, the electorate, don't really want to. There's always something more important to do before we get there, and future generations can deal with it. Bill Gates has said, I think last week, and he did forecast the pandemic, that he thinks this has set us back 20 years. So it's going to be a real challenge. And you may ask yourself, but why Hackett and the Building Safety Bill? Well, there is actually going to be a huge focus on fire safety in the coming years. Everyone must be safe from fire in a property. And when you simply focus on fire safety, you probably end up seeding the building pretty well and make it fire safe. But you can still value engineer the other bits, the ventilation, you know, the stuff above the ceiling that you can't see, that you can't really value. Do what you want with that. And in 10 years, I'd say we'll end up with a series of studies about the poor living conditions in the new homes that we're building. And incidentally, in the days when £1 billion was a lot of money, the NHS spent 1.3 billion a year dealing with the health outcomes of poor housing, which is a scandal. So my argument is that actually the way to build low carbon buildings is to start with designing a building that meets the design intent first. We need to learn to do that at scale, not the odd passive house here or an exemplar estate there, but every single time. Because if you build the home properly, it will be safe. You don't build it to be safe, it will be safe if you build it properly. You're going to hear a lot of stories today about great technologies that work, and they really do. But they only work as part of a holistic integrated system. And that is what a building is, an integrated system, not a series of components assembled at the cheapest price to look like the planning application drawing. We should be as rigid as the oil industry about meeting technical standards. That was brought about in the oil industry through the Piper Alpha disaster. And here the industry really reacted quickly. A report that says this was a tragedy that could have been prevented and promises legislation to make sure it never happens again. But where's the action? And that quote actually was not from Grenfell, not from Piper Alpha, but actually from the Boeing report that was published only yesterday on the 737 MAX crashes. But do you think the aircraft industry will change quickly and get it right? I would bet they would. Why 3 years after the tragedy of Grenfell do we still have people unable to grasp the need to change? And I'm going to end now on some numbers, and I'll be very brief. 20% of the design is complete before we start building. We talk about shovel-ready projects, and that drives you down the road of build and design, which is a disaster for low-carbon buildings. 200% is the average energy consumption above the design intent of buildings. And that has to be wrong, because if it's wrong for energy, it's wrong for everything else. 2, there are 2 suicides every day in construction industry. So not only do we have broken buildings, we have broken people trying to build these broken buildings through hurry-scurry programs, through money, through all kinds of stresses we put on them through a broken process. 40, the amount of carbon that buildings emit is around about 40%. So the opportunity for low carbon is massive for us. We're the people who can deliver this. And the final number, 90-90. 90% of people spend 90% of their time in a building. Therefore, if we get it right, we can make an enormous difference. We should not apologize for the cost of what we can deliver. If allowed to properly design and install heating and ventilating services that work, because the overall cost of in the life of the building is marginal, to society, it's a massive ability to make change and combat climate change. We should call out those who cut corners, including clients who prefer that £500,000 marble reception desk to a proper working ventilation system. In other words, we need to take the lead, show leadership, and not wait for someone to solve the problem for us. And finally, if COVID has done nothing else, it's given the public and many professionals a better appreciation of why you need good ventilation, a good design overall. And on that positive expectation, I will say thank you, and I hope you enjoy what is really an excellent program today. Thank you.
Well, thanks, David. We have precisely 1 minute to do what I know that you do when you have interviewees on your webinars. So I'm going to turn the tables and just ask you a quick question off the cuff.
Okay.
How confident are you, or what kind of timescale do you think it will take for the building safety recommendations to really filter through?
I think we asked Dame Judith Hackett this in one of our webinars, and she said once people get their collars felt, then it will be, and she used that precise term. I also think insurers will drive a lot of this. I think you will find it really difficult to get insurance if you can't evidence that you're competent and compliant. That's my hope. So I think it may be a year yet, but it's coming. It really is coming.
Thank you. You're going to be coming back to help us to tie things up at the end of the day, I'm hoping.
I am.
So we'll see you later, and we'll have a chance to ask some of the questions that have come in. There's one question, but I can't ask it, it's too long. But we'll get back to that. But we'll see you a bit later to do the session, which we've called Tying It All Together, which is a very brave ambition, I think, of us.
It is. So I'll head back to Sky Sports News to see that Tottenham have signed Gareth Bale in the meantime.
But thank you for the history lesson. I think we can all honestly say we've learned something. And for the first time today, I will use the phrase "without further ado," because I'm sure the eagle-eyed amongst you will have seen that our panelists for the next session have already joined us, which is gratifying because I can see now that all the people that I expect are here. So, gentlemen, if you'd like to put your video cameras on, and we'll introduce you. So we've got Steve Sutton, we've got Phil Hurley, and we've got Rob Whitney with us. Now, these gentlemen have the most invidious task, I think, because we've given them key challenges for heating, and we all know that there's been quite a few challenges brought up since we last met last year. I put a few of them down on a bit of paper. So you could choose boiler bans or not, depending on your viewpoint, net zero, hydrogen or heat pumps or something else, incentives, regulations, training skills, digital, smart, AI, and the list could go on. So what I'm asking you gentlemen to do is to pick one to begin with and tell us what you think the key challenge from your perspective is, and then we'll have a discussion about it. Now, I was going to do it alphabetically, but then I thought, no, I'll drop Steve in it first. So Steve, could you go first and give us your perspective, please?
Right, so in our membership HHIC, we have manufacturers who produce domestic heating products that include gas boilers, heat pumps, direct electrical heat products, heat interface units, and heat recovery devices such as passive flue recovery and wastewater heat recovery. Also secondary heating such as electric and gas. I think we have a lot of challenges. In new build, we have the opportunity to increase fabric, but we do need a combination of ventilation as well. And we've been doing some of this through the SAPIF meetings that we have held with BAYS. And so both the new build and existing properties, we have to adopt a fabric first approach to reduce energy demand. This is the simplest way of reducing carbon through the adoption of energy saving measures. The cheapest form of energy is the one you don't use. In new build, we have to balance insulation with heat and hot water demand, along with ventilation, which means we can use lower carbon technologies such as heat pumps. The ultimate goal we've been working on with BAYS with the SAP Industry Forum for 2025 is to have passive houses where heat demand is very low and the highest energy demand is hot water. And manufacturers with new technologies are encouraged to join this forum. For houses built to opportunity and insulation upgrades, heating system improvements where required to move the consumer to low carbon technologies such as heat pumps. Members would like to sell more heat pumps, but the question is, what is the incentive to the consumer to swap the high performance gas boiler for a heat pump and a storage tank? Possibly a government incentive may be required. So we have a lot of technologies out there, but I think it's probably just a horses for courses type approach.
That's very magnanimous of you, Steve, to end on. So we'll throw straight across to Phil on that pump, representing the Heat Pump Association, and your perspective. And I guess we're trying today not to present this as a boilers versus heat pumps. No. It's about collaboration, isn't it? But it's about how we get that message over, I think, to the populace. Phil.
You're totally correct, Andrew. And the challenge is immense, and in fact it's frightening what challenge we've got to achieve this. So the government say we're in a climate emergency. They've already set the target of 2050 for net zero. So we're already on that trajectory now to actually achieve it. Policies will come to achieve it in time. They've already reduced the ban on petrol engines and diesel engines from 2040 to 2035 to phase those out. So there's a trajectory for that. And we must remember, I think David said it, I thought it was slightly higher. He said 40, I think it's 50. 50% of all carbon comes from our buildings for cooling, heating, hot water and ventilation. So the challenges from buildings. We've done a great job in decarbonising the electric grid in the last 10, 15 years. Fantastic job, one of the best in Europe and one of the best in the world. But the key challenges are to continue decarbonisation this transport and the buildings we work and live in. So that is the immense challenge now, because nothing really has been achieved in those two areas. And the biggest challenge is the 26 million homes we all live in, and 80% of those at the minute are fossil fuel and gas, and 1 million oil boilers, and very few low carbon solutions at the moment in time. So that is the biggest challenge. So to me, it seems silly that we're arguing about, and there is arguments about, especially from house builders, that we're debating about tightening the building regs, because we should be building homes now which are basically carbon zero or as much carbon zero. We had a target of 2016 of carbon zero, and that's gone. We've actually gone backward on that. It's absolutely crazy that we're going to build homes today that in 10 or 15 years time we're going to have to refurbish again to reach the net zero target. That's just criminal. And back to the original question, it's not about technologies. Yeah, I represent the Heat Pump Association. I'm a heat pump manufacturer, but I fully recognise there's no silver bullet. And if we're going to achieve these carbon reductions, it will be a mixture of technologies. Okay, definitely will be. Heat pumps are not going to be every home replacing a gas is going to be heat pump. I totally recognise that, but we must be realistic that heat pumps are the only technology at the moment which we can achieve the carbon emissions we want in homes now. We can't wait 10, 15 years for unproven technologies or be waiting years for hoping something's going to come along and miraculously help us decarbonise. As the government say, we're in a climate emergency. So heat pumps have a role to play now in getting us on that journey to carbon reduction. So the big challenge for me is how we do that. And the Committee on Climate Change have come out with some figures to achieve net zero. And basically we're going to have to be installing at least 300,000 heat pumps by 2025 and at least 1 million heat pumps a year by 2030. And to actually achieve net zero, 19 million installed by 2050. So that is mind-boggling numbers to actually achieve now, when we're only installing less than 30,000 units a year now. So that is the biggest challenge for me. How are we going to achieve that? And the biggest challenge is upskilling installers. Okay, if we look at installers who are trained for heat pumps now, it's MCS. That's the main standard of heat pump installers. And there's less than 1,000 installers. Okay, there's over 130,000 gas installers out there. Okay, the challenge is, how do we upskill them to actually raise to the challenge of installing the numbers we're talking about? That is the biggest challenge for me, and something we really need to work on to actually achieve, because if we don't do that, then we're never going to get to the numbers and we're never going to reach our carbon targets.
Have you got an answer to that self-posed question, Phil?
Well, that's what we're here to talk about in the discussions.
Okay.
Yes, I've got the solutions.
You've got some theories, right? I'll let Rob say his piece first, and then we'll tackle all that. You've between you so far, you've lobbed a couple of depth charges in for us to tackle. So, Rob, over to you, and then we'll have a discussion.
Yeah, great. I mean, absolutely concur with both what Steve and Phil have said already. You know, it's not a single vector approach. We need to stop all the sort of infighting in the industry. It's counterproductive. We all know what net zero is about, and we all know what we need to do to get there. I don't think the problem is the technology. Okay, whether it's a boiler or a heat pump or a direct electric, I don't think any of that actually matters. What really matters is the systems and the homes that these boilers and heat pumps are being attached to. And really, I think we don't have to look too far in the past of our recent history to see another example of a policy not really filtering through to the outcomes it's needed. I'm talking about condensing boilers. So in 2005, there was a mandated regulation that no more non-condensing boilers were fitted. That was great. You know, everything's an A grade. All of a sudden, everyone's saving money. Well, the reality was somewhat different to that. And actually, what happened is that the condensing boilers got fitted in the same way that the non-condensing boilers got fitted. Oversized boilers running at too high temperatures, very rarely condensing, and the skill set for the installers and the training to be able to do the heat loss calculations, to size the radiators and do the balancing and fit them with proper controls that modulate the boilers rather than just switching them on and off at maximum temperature, running them for a few hours on and off. That's the enemy of efficiency, you know, regardless of what appliance is being fitted. So what I'm heartened to see is that the proposals for the Future Home Standard and the new version of SAP are talking about running systems at lower temperatures, below 55. That helps condensing boilers to condense, and it also helps heat pumps to get maximum efficiency, the COP, because you can't run a heat pump at the really high temperatures that you run gas boilers at and still expect the same COP. It's all about low flow temperatures, low and slow, nice large radiators in homes that are properly insulated, and draft proof. So I think the challenge is really upskilling the installers and training those new generation of installers on low temperature heat. And then that solves all sorts of problems. So really the training, I think what we're seeing more and more is really a hunger for training amongst the installers. And too often in the past, the training has been too siloed and too specific to the individual things the manufacturers have been selling. So you go on a boiler course, they tell you how to fit the boiler, they don't tell you how to fit a system. The radiator companies are telling you how to size radiators, controls companies how to wire in the thermostat. What we need is a holistic approach to training. And too often the heat loss and the system tuning and balancing is just overlooked. The installers are recognizing this skills gap now and actually solving it themselves. There's some really good ex-installers that are offering training courses on how to do low temperature heating design and design for, in the case of boilers, condensing. So I think that's the biggest challenge.
Yeah, it's a challenge, all right. The wires are alight on the questions with mainly around skills, and the general theme is these are huge numbers. Everyone's alarmed out in the audience now. Huge numbers. We need a huge number of people to be upskilled. What are we going to do about it, and why haven't we done something about it already? Because this is not very far off the carbon targets.
No.
So you mentioned a solution, Phil. Do you want to fire in?
Yeah, I mean, you mentioned why hasn't done before. Basically, there hasn't been the policy to do it because 1.6 million, 1 million gas boilers installed a year. There's nothing being in legislation to actually change people not install a gas boiler, building regulations or whatever. They're just being incentives on a monetary for going away from fossil fuels, which is fine, and you'll get your early adopters. But if we're gonna have mass carbon reduction, then there's got to be a bit of stick as well as carrot, and that goes with policy changes. So we are seeing installers now looking at alternatives to gas boilers because they can see how the market's going to go, and they're very interested in training. So training is paramount, and it's upskilling, because let's not forget, heating installers, they've already got the skills. Okay, a heat pump is no different from a gas boiler. That you're still piping up, you're still piping the radiators up. It's very, very similar. It's all in the design, okay, and it's a lower temperature. So what's happened in the last 6 months is that various key stakeholders have realised this, and Rob just mentioned that then is mandating the lowering of flow temperature, because if we whichever system goes in, we mandate the maximum flow temperature, say 55 degrees, and I've got it on good authority that may come in the new building regs next year. Now if that happens, okay, that makes any heating system more efficient, gas, because they're in condensing mode. But what it means is that once that system's in gas, let's say, that when that gas boiler comes to its end of its natural life, then we haven't got to rip out the whole system and start again. And that's what's happening now in existing homes, is that obviously we've got to change the heat emitters a large proportion of the time. So if that does come into place, then we need proper training for low temperature heating. So a course is just being developed at the moment, which is a low temperature and heating and hot water course, which takes into account room by room heat losses, because you would need to do a heat loss. Pipe sizing is important if we're lowering the flow temperature. Hot water, because if we go in towards maybe heat pumps or low temperature heating, maybe more cylinders. At the moment, most gas boilers are combination boilers, so no hot water cylinder, and hydraulic balancing. So they're important, whichever heating system you actually install. And if we're training installers on how to do good heat loss designs, hydraulic balancing, pipe sizing, then all systems benefit. But what it means is that gas boilers are still going to be installed for years to come. That if that is done now, then when those buildings are actually updated, then the transition to a heat pump is easier. Then on top of that, we're actually developing a new heat pump course, which because of the low temperature heat and hot water course, it means that we can concentrate on just an upskilling of the heat pump design, because out of that course, we shouldn't be having to train installers on how to do heat loss calculations and as such hot water sizing when they're coming on a heat pump course. They should already know that. So hopefully the low temperature heater course will be a prerequisite for the heat pump course. And the heat pump course will be developed to give installers, existing installers, the necessary skills onto upskill to be able to install a heat pump. And that again is being worked on at the same time. And both these courses are planned to come online by the end of the year, early next year. So courses will be available for installers to find the necessary skills. The challenge after that is apprenticeships and new entrants to the market. That also needs looking at, and it really needs apprentices looking and people entering the market looking that low temperature heating, low carbon solutions are the future, and having a route to be able to become a low carbon installer. That also needs to be attractive for new entrants, and especially young people and apprenticeship. So that's the next challenge to work on after we've done the upskilling of installers.
So either of you gentlemen want to leap back in, because if not, I'm going to throw in a few more comments from the floor along the lines of, why don't we just make it mandatory, this training?
Yeah, I don't mind. Yeah, I think the training is a good idea, and the and upskilling the engineers is key to making sure that we can do this transition. I think what we have to remember though is that the consumers at the end of this as well. So you have to remember this is probably going to cost more money. So government has to think about this and their policies and how they support this transition process, because it's very, very key that you can imagine COVID-19 at the moment is taking a lot of money out of people's pockets.
Yeah.
And going along to somebody and saying this is going to cost you quite a bit more money to have your heating system installed could be a little bit of a problem to people. So we do need to make sure that government understands that, and that you've got the right policies in process to support these different schemes.
Any sign of that? Because I'm just getting a bit of feeling of deja vu, Steve, because we talked about this last year. Yes. How we're expecting the route map, or the whatever they were calling it, for heat.
Yeah, I think it's not there yet.
Tell me it's COVID.
Yeah, I think COVID will stop quite a lot of things because of the shortage of cash. I do think that we should remember the fabric first approach as well. We can upgrade the fabric with some properties, which means that the radiators may not need to be replaced if you want to fit a heat pump. If that's the case, and then you're saving quite a bit of cash there, and it makes it easier to do a sale to the consumer, I would think.
Yeah, if I can just come in on that one. I mean, the thing that needs the innovation is the business model. Yeah, the technologies kind of exist already, maybe not all joined up together, but they do exist. And we talked about decarbonisation of the grid, but the grid needs a lot more innovation and development on it. And if we're going to get this tool joined up, we need a flexible smart grid that can also drive demand as well as respond to it. We got to invest in other things like ground source heat pumps and battery storage as local infrastructure. Those are the network pieces. You know, we haven't really touched on district heat yet, but that's an important one too.
Yeah.
You know, these finance models are really, really important. You know, rather than a piecemeal approach, if you had a big, deep retrofit that could have the fuel costs that you have to pay for, that's a really excellent approach, and it solves things like fuel poverty as well. But these deep retrofits are really expensive. I mean, you're talking 30, 40K on an average property to do that, you know, with all the big insulation updates on the walls and the roofs, the windows, and then a smart energy low carbon system. So, you know, there's been some pilot projects that are rolling out on that. And really, to achieve net zero, that's what's needed, not a piecemeal approach, piece by piece. It's these deep retrofits. And it's,
sorry, I was watching the news this morning and they're talking about more rental schemes may come online for different things.
Yeah.
We may see rentals come into the heating sector.
Yeah, it's called heat as a service.
As a service, yeah.
Yeah, you pay for your heat rather than the fuel.
Yeah.
And you sign up for, you know, a long period, 10, 15 years or so, and then the company will come in and actually refit your house completely, and then you just pay them like a subscription model, like a mobile phone, for heat rather than buying fuel, and they provide all of the updated appliances and everything to go with it.
Yeah. Can I just come back to really interesting topics there, but can I just come back to training? And you mentioned, Andrew, about somebody mentioned making it mandatory. Now, one of the ideas we've got, and Rob picked up on it when we moved from condensing boilers. Okay, the market at the time said it would never happen, but it happened overnight, and it happened very simply. Okay, and installers, the building regs changed. Okay, made condensing boilers mandatory, and all installers who were installing combination boilers, or sorry, condensing boilers, had to go on a energy efficiency course. Okay, so the low temperature heating hot water course I've talked about is very similar to that, and that could be mandated within the change of the building regs. But also, installers who are installing gas boilers go on ACS courses or gas safe. Okay, every 5 years. Okay. The low temperature heating course, if we're going to go down the low temperature heating route, then that could be mandated that within the 5 years, that when a gas installer needs to update his gas safe, that he needs to actually do the low temperature heating and hot water at the same time. So within the next 5 and 10 years, then that would mean that all installers are actually trained to do low temperature heating. And I think that's a very fair way, an easy way of actually getting training done and mandated. Very simply, but also giving people time to actually undertake the training, because they will have a 5 years to actually do it, so before they do the ACS refresher course again. So I think that's probably one of the ways to go. And then the other area is skill cards. Okay, if we're going to have these different technologies, another area is to develop skill cards. So an installer has a skill card and is able to represent what actually skills he's got for technologies. So it could be gas boilers, it could be hydrogen, it could be hybrid, it could be heat pumps, air source, ground source, or whatever. And that could be on a national register. And going back to consumers, that in consumers then can see what actually skills their installer coming into the house has actually got before they undertake their services. So I think that's an interesting route. We're really interested in a skills card as a way of going, as well as mandating it, the low temperature heating course within ACS.
Yeah, Andrew, can I just make a point on that? I think
you can, but just bear in mind that we've got quite a few audience questions I've got to throw in amongst you when you've finished discussing amongst yourself. It's fine, but yeah.
If we go down that route, I think it has to be like a national scheme that covers all sectors and not just heat pumps and low temperature. If you see what I mean? That's Robert's point, really.
Yeah, it's low temp I'm talking about. It's not heat pump. I'm not managing they've got to do a heat pump course. It's a low temperature course. And if we're going down low temperature, it helps heat pumps, but obviously it helps every system. If hydrogen comes on board or hybrid, then any system we put in people's houses, we want it to be the most efficient possible.
Yeah, it's driving efficiency, isn't it? And low temperature is equal efficiency, whichever appliance.
There's a few people out in the ether saying, let's not talk about technology so much as the pathway. You know, we should talk about not necessarily the specific pathway, but drive people along that. You know, you need to reduce carbon in one or two of these ways. And we should mention part of the portfolio of solutions is heat networks. And it's been pointed out that heat networks in themselves can be technology agnostic. You can use many different technologies at the heart. And again, that's a bit of a mindset, isn't it? Because for networks, you've got to start approaching things very differently. It's not, as Rob was saying, it's not a siloed approach in terms of individual buildings so much. It's you've got to go wider, which brings us on to another point from the audience, which is, yeah, there's so many different associations and they're all pushing their own agenda. This comes up every year as well. Couldn't we all just get together and be a big heat association? And
yeah, we'd be quite happy for everybody to join HIC.
There you go. I knew this was going to start it off. There's a serious point, I guess, about
the industry anyway. So yeah,
I guess there's a serious point about, is there a, you know, could there be a sort of overarching, I don't know, body or that everybody could sign into, or is there already? I mean, one of the things about all the low carbon and net zero strategies is you have started all meeting up a bit more across disciplines, haven't you? There's been a few committees with
and I think that shows it's collaboration, and it's putting aside party politics, and an example of that is the training courses we've developed. That's been an amalgamation of different associations working together, because and that's the way to go. It's collaboration, because the target is net zero, okay?
Yeah.
And we all want that, and it's working together to achieve that. And I'm quite open. Heat pumps are great, don't get me wrong, I would say that, but I know it's not the silver bullet, and it's going to be a mixture of technologies, and I think we all need to realize that and work together to be able to achieve that. And low temperature heating is the easiest one we probably could all agree on. I think low temperature heating and training is something we all agree on without technologies, and if we work on those together, then the others will come, and then it's open playing field, and the best technology will win, or whatever best technology is for the consumer will win.
And it's the controls that tie everything together, Bill, because, you know, unless we can have the appliances which are energy smart and work together with the grid signals and with the demand, it's not going to tie in properly. And, you know, you've got a situation now where you've got all these different appliances in the home, all using energy at different times of the day, and they need to be run intelligently according to grid signals. So when the electricity is particularly cheap or low carbon, to pull them in, or if the grid is really struggling and it's high carbon, you pause them and switch them off for a bit. That's really the key to all this, and some of the work that we've been doing across industry on the 2025 regs has been all to do with that, how we make the homes intelligent and the appliances that are in them part of the solution rather than part of the problem.
Yeah, no, I totally agree, and that's, I always say that part of it is the sexy part of it is that is going to happen. It's how everything is joined together: EV, battery storage, home appliances, when the wind blows, boosting your heating system, boosting your, all that is got to come. And it's a way of shaving the grid, because one of the old adages is that we're going to have to build 20 nuclear power stations if we're going to go electric. It doesn't have to work with that if we've got control over all the electrical appliances in the home. We can give grid shave and switch appliances off, on, boost when we need to, and that's I think the sexy part of the way we're going to go with heating. And people get turned on to that. I mean, let's look at Google. Have got Nest. Okay, why do you think they're doing that? They're not doing it for just heating. They're doing it to gather information, and then I would think somebody like Google, it'll be heat of a service. And as Rob suggested, that is the future. That's what we're moving to. Technology is moving so fast that it won't be about the boxes outside or the box on the wall. It will be about the technology which controls it all.
Yeah, it's a smart integration, and I'm glad you brought up Nest on that. Other thermostats are available, of course.
Of course.
I was going to say literally that for you, Rob, actually, just at that point.
One of the collaborations we've actually been doing is working with BASE with the different thermostat manufacturers to get everybody's thermostats recognised, because when one manufacturer brings out an innovation, everyone obviously jumps on that as well. Everyone's got to be recognised. So the good news is that all these technologies are not just flashy things on an app. They actually save real money for real people. And you say, as I said, pulling it in and out when there's grid demand and grid signals is absolutely key. And if you can have a home that has a blend of different energy sources to make the best use of the right one at the time, be it the solar on the roof or the hybrid system or the heat pump, that's where we're going to really shave all these small amounts to achieve net zero.
We're getting to the point where it's 10 minutes to go, so I'm using this to address the audience first of all, and then we'll come back to, we'll allow you a couple of minutes to think, well, what important points do we still need to get across? There's about 100 on the wires at the moment. Just to say, audience, can you use the Q&A function, not the chat function, for your questions, because I can only keep track of 20 things on the list at a time, and then I could tick them off on the Q&A. Also to say that the technology, we'll be getting into detail with the technology side for both hydrogen and for heat pumps and the electric grid later in the morning. So there'll be more time to talk about the technology of grid balancing. And I believe we'll also be hearing about an interesting project in Oxford, which is aiming to tie up huge battery storage with electric vehicles, heat pumps, and all the other good stuff. So yeah, it is about collaboration in a very real sense, and technology collaboration as well. Plenty of people asking, incentives. How can, you're asking installers to train. They need an incentive. Is there any progress on that? So Green Homes Grant we should throw into this, which has appeared since we last all met. Is offering some money for some things and not for others, so that's a little bit controversial, I think. But has that, have you seen an impact with that already? Anybody?
Yeah, I can come in on that one. Obviously, we've been hearing about it for some time and really keen and eager to find the detail of what it is and what it means for the different technologies and for consumers, and that's gradually coming out now. Unfortunately, what we're hearing is that the installers that could be part of that scheme, obviously they have to be part of the MCS or Trustmark or other schemes. They're already tied up with the Eco3 work, yeah, and there's a huge backlog because of the COVID lockdown. So they don't really have much bandwidth to engage in the Green Homes Grant, unfortunately. So yeah, where I think that's well-meaning is, unfortunately, it's excluding a lot of the sole traders and small companies that would all normally be really keen to be involved in it, because they don't have the Trustmark yet. They've not had that traditionally. So I think it's a bit of a shot in the foot because it's been rushed through. And I think if the industry had been consulted better and more engaged with it, and it had been planned in sort of 3-4 months in the future, there'd have been a lot more interest in it. But what I'm hearing is that, particularly on the heat pump side, is that those guys are busy, really busy.
Yeah.
Everyone's talking about
and there's not enough installers, and the installers we've got, they're busy with their own work at the minute, and we've only got several months for this scheme to work, so it really needs extending, in my view, or delaying.
I think the mechanism for applying for the vouchers and redeeming those vouchers, and the installer will have to trust a lot, I think, that they're actually going to get paid, because the voucher can't be completed until the work's been completed. So there's going to be months of waiting, cash flow problems as well. So hopefully all this will get addressed, and it's not a worry, but I think it is a worry.
So from the audience, we've got just a comment, which is, who's going to pay for all this? Who's going to pay for all this? The training and the technology, I guess, but mostly the training. I think the industry is worried that, where's the cost going to be built in for the additional training?
I think what we're doing is speaking to BEIS, and they are interested in regarding some sort of voucher scheme for installers, especially the early adopter installers. The energy efficiency course was subsidised, and it was subsidised through training providers and manufacturers. So we're advising on a similar model to that. So the early adopters, the installers who are wanting to move into low technology, into low carbon technologies, can move in and be subsidised. Maybe now up to 2024 when the incentives for heat pumps are running, and then after that 2024-25 is probably where the stick happens, where policy is mandated, and you would have to do it, else you won't be able to install them. So there has to be a point of where carrot phases out and stick becomes the tool.
We've just been asked for, can you provide details of the low temperature heat courses that you're talking about? Is this a finalised thing yet, or is this to be advised?
It went out for consultation in June, so the consultations finished. Unfortunately, if you didn't catch that, it was widely publicised in the press, and I think we had a very good response. I think we had over nearly 400 responses to the consultations, and I think 90% of the people who replied were installers and installers who were basically under three people, so one-man band installer, which is great. They're the ones who obviously install the most gas boilers. So it's important that we get their feedback if we're developing courses. They get forgotten a lot of the times in the vans, that they think everybody's making decisions for them and they have to pay for it all. So it's important anything we develop in the future involves installers, because they are key to everything. They're our best salespeople. Every day they're entering people's homes and selling equipment. They're our best salespeople. So we really need to engage with installers.
So we're reaching that point where I'm going to have to ask you to each come up with the one thing that you want people to take away with them from this opening session. I told you I gave you the most invidious session of all, and I reckon we've covered about 25% of what we spoke about. But the rest of the morning is available if you want to stick questions down. Anyone in the audience for things that haven't been answered yet? So let's do it in reverse order then this time. Rob, what's the one key thing for people to take away?
Digital communication is the one thing to take away, and I'm talking about between the appliance and the controls. We got to stop running things flat out on and off. Yeah, that's not how we can be efficient. We have to modulate the output of our appliances, and really that opens up all sorts of other opportunities. It's remote fault diagnosis, and how much fuel you're using, how efficient the appliance is going. So please guys, if there's one thing you can take away, look at the load and weather compensation controls that are on offer now. Start using them with your gas boilers, because you're definitely going to need them with your heat pumps and hybrids and all that other stuff. And then that obviously leads into your energy smart controls that can take your grid signals. We've already got some great applications with Evo Home products that are taking inputs from Octopus Agile tariffs and running out of hours and pulling in the immersion heaters and all sorts of things on those grid signals. So tomorrow is here today, and the digital revolution is just starting. Thank you, Rob. Phil?
Yeah, I'll try and be a bit shorter than that. Train installers is a key one, and get them to raise to the challenge of decarbonation, and skills and best practice need for installers. They're the key ones we need to, because without those, it's not going to happen. And without the installers trained, and a good quality training, good quality installs, and good quality best practice, it's everything together. And if we do that, we're going to have obviously good installers and at the end of the day, happy customers. Because if we haven't got happy customers, it's going to go nowhere.
Thank you, Phil. And Steve?
I'm going to be cheeky, Andrew, and pinch two off you here. So. I'd like to make sure that people watch the green gas element of this that you've got on later, because I think that's very key to the future of what we're doing to decarbonise the gas industry. So I think people should watch it and try to understand what's going on, because it's quite key. And then I think the other thing I would ask people is that new build's very important to set standards, and we need to improve what we've got in the new build area. And if there's anybody out there with new technologies that we can include in new build, I think we should make sure that they're making sure that BAEs and people like that are aware of these technologies, and we should be pushing new technology to make things more efficient and reduce carbon.
Thank you. Having wrapped that up, we because of the logistics of sliding in the next session, we have time for one more question. It's like sound a bit like David Dimbleby now.
Oh.
What do you think? This is quite an interesting one. I see people actually appearing here. Can the new panelists, if you can turn your video off, that'd be great. Thanks. What do you think the strong and/or weak link is in this, in moving forward? A few people have said developers are the ones you really need to crack to get things moving in low carbon. Or is it the government? Or is it us, the industry?
It's policy, and it's concrete policy, so people can plan, and that's all people want. They want to plan. Builders will build to whatever building regs are set, so they'll always find the cheapest options around that. So it's concrete policies and a direction of how we're going to achieve it. It's okay saying we're going to achieve net zero, or we're going to phase out high carbon fuels by 2030. We need a roadmap of how we're going to achieve that, and without that, nothing will happen, and you won't get people into the market. So it's a clear policy of how we'll achieve. Not that we're going to change it tomorrow, but as long as people know what's going to happen in the next 2, 3, 5, 10, 15 years time, then people can plan.
Yeah, it's that confidence and that stability that we need, really, for all these SMEs to start up and get trained and have confidence that this is all real this time, yeah, because we've had several false starts before.
Yeah.
Yeah?
Yeah.
So stability
Exactly.
in the regs and the roadmap, really, really important. I think everyone is on a mission now, they get it. And really, I think a lot of it will be driven through from consumers. The regulations are great, but they can't keep up with technology. You know, it's kind of almost a losing game to try and do that. So you look at the things like Elon Musk has done, yeah? He wants electric cars, and he isn't worried about that there's no chargers. He makes the chargers, and that's the sort of big picture thinking we need.
Yeah, I think if we go back 12 months, Andrew, then decarbonisation of the heating industry was top of the government agenda, but COVID is probably there now. So I think the industry needs to work together to make sure that we keep it high on the government priority list. Because if we let it slip, then we won't get the support and finance that we need to move forward.
That's a very carefully veiled advert for associations, I think, there, isn't it? Very good, Steve.
Member of associations and working together, we have proved does work and
Indeed.
get things done.
Lobby your associations and they can lobby your government. Thanks very much then, gentlemen. That's excellent. And the nature of things is that we effectively slide you out and then slide in the new session with barely a moment's breath. I might just take a moment to have a sip of water. So thank you very much, and you may leave the session.
Okay,
Thank you. Goodbye.
Now, while that's been going on, you've seen new names appearing on the screen. Again, that was our first session. Lots of questions, many from you, many of which weren't sufficiently answered. We will return to, as I said, to the themes of heat pump and electric grid and hydrogen. In fact, right now we're going to go into hydrogen. Just keep them coming in. We'll do our best to answer them. And if we can't answer them in person, or you don't get a satisfactory answer, then please do email or keep sending the Q&A in. Keep repeating the question if you don't feel you're getting the right answer. We'll do what we can. Now, one of the joys of chairing panels like this is I have bits of paper in front of me. I have 2 screens and questions and answers flying in. So at this point, I should say, don't concentrate on me when my eyes are darting around all over the place, particularly when I go cross-eyed when the Q&As come in. I have a big screen to this side. And I'm also looking at you, the audience. But now I'm joined by the next session. All our all our speakers are in place. So welcome to Hydrogen Only, to Tommy Isaac and to Jeff House, who are going to go in focus. I think that was what we called it, in focus, into hydrogen. And everybody is very interested to learn what has been happening in the research side. And I know you've all been developing in your various ways. And so what we're going to do is ask you individually to talk about a little bit about what your sector has been up to. And I promised Tommy that he could go first. So we'll go Tommy, then Heidi, then Jeff, sort of wider, and then drill down into the appliance side. So Tommy, would you like to take the stage? And the other guys, if you want to just whip off the video, is probably a good thing, and mute it. Thank you very much. Tommy.
Good to be with you this morning, Andrew. Thank you for the invite. What I'll do is give a introduction to this sort of state of play as to where what the closest goal is with hydrogen at the moment in the UK. I'm conscious that there'll be lots of questions that that probably arise from that, so I will try and be brief, because it'd be good to leave lots of time to answer questions, so people feel like we're actually engaging with them. So my name's Tommy Isaac. I'm the principal engineer for Progressive Energy, but my actual role is the project management of the HyDeploy programme. So the HyDeploy programme is the only blending programme in the UK. What we are trying to do is create the evidence base that that demonstrates the safe transportation and use of the 20% hydrogen blend. So the thinking behind this is to enable blending of hydrogen at much sooner timescales than conversion can be achieved. And then what this would enable is a supply chain of hydrogen to be built up, to then start to convert regions of the country in a kind of nucleus fashion, where you have spots of conversion that then gradually get bigger and bigger and bigger. So the idea is that blending is the first practical step along the hydrogen pathway, because it can be delivered within the current appliances that are being used by or in people's homes. So to enable us to develop the evidence and have it supported and approved, what we do is run trials. So we are currently in the midst of the UK's first hydrogen trial at Keele University, where we're providing a blend of hydrogen to 100 homes and 30 university buildings. The approval for that trial was achieved via an exemption application to the Gas Safety Management Regulations hydrogen limit, which the HSE approved. This took about 18 months of research to underpin a safety case to be put forward to the HSE, and I'd be happy to take any questions on that to then run through it. And then that ultimately led to the building of a 0.5 megawatt electrolyzer and a Greenwich unit, and be able to supply the hydrogen to the customers. Where we are now is we are in the midst of the approval process for the next trial. So that is a public trial in the northeast with Northern Gas Networks, where we're looking to provide a blend of hydrogen to 670 normal homes in the Winlayton area of Gateshead. And we're looking for that trial to kick off in Q1 of next year. So there's lots and lots of progress being made in the hydrogen space, and lots of research that is being generated to support the safety case for hydrogen blending. If we take a slightly more macro picture, it is very likely that we'll see mass blending of hydrogen by around 2025 here in the UK. So the closest programme that's looking to deliver bulk programme is the HyNet programme up in the northwest, which is currently deep in detailed engineering and is looking to be operational with bulk hydrogen production and distribution by 2025. So this is something that is, although maybe a few years away, is actually fairly close in terms of our energy system. So that's probably all for me at the moment. I'm happy to take any questions if I've got any time left, or try and answer any that have accrued over time. If not, happy to hand over to Heidi to go through hers.
Let's hand straight over to Heidi, and we'll roll in some questions at the end, because that'll give me time to read them all.
Okay.
So Heidi.
Hello, I'm just checking. Can you see me?
I can see you.
Okay, you can see me, and can you see my screen?
I can now see your screen, yes. It's all working well.
Okay, I've just got a few slides.
Great.
But hello, thank you very much for inviting me here for this session. Just by way of brief introduction, my name's Heidi Giannoni. I work in Arup Energy Advisory. At Arup, we're working across all different aspects of the supply chain of hydrogen. But my particular role and focus has been working and deeply involved with a high-for-heat program, which is looking out at the end-use application of 100% hydrogen. It rolls in quite neatly from what Tommy was just talking about with regards to the high deploy work that's underway at the moment with regards to 20% blend hydrogen. Obviously, in order to get to net zero by 2050, we're possibly going to have to move to 100% hydrogen future. And certainly organisations like the CCC, Carbon Climate Change Committee, recognise the important role that hydrogen has got to play in the future decarbonised scenario. And really, in order to get to that position, we're undertaking the work now on programmes like High4Heat, which is sponsored by the government department BASE, to provide that evidence to ensure that we can get to that potential end state. So moving into just a little bit about High4Heat, if people don't already know about the High4Heat programme, it's focused on gathering all the evidence and determining whether it's possible and feasible to use 100% hydrogen in our homes and appliances, so appliances like boilers, cookers, gas fires and so forth. And the reason why this isn't really important is because the recognition that over half of our energy consumption is through heating our homes, and that contributes to at least a third of all the carbon emissions that are made. So we really do need to look for a way of how we can decarbonise our systems. So High4Heat has a number of different, if I can change onto the next slide. Yeah, so just by way of very brief overview, there's a number of different work packages within the High4Heat programme. The programme started back really in earnest in 2018, and since then we've made fantastic progress with the support of industry. There are a number of different work packages, but to cover the areas broadly, there's development that we're undertaking in terms of developing hydrogen standards. There's work that's been undertaken in terms of developing all the different appliances that may be needed to be used at end use. And then also very importantly and critically is the development of the evidence to support the safety case before we move into demonstrations and then potential future community trials. So just touching on a few of those areas to give you an insight into some of the progress that we've been making. We do have a website for the programme and we provide regular updates, so I would encourage anyone who's not had a look at that, please do have a look at that. However, to touch on a few areas, so in terms of standards that are being developed, IGEM, which is the Institute of Gas Engineers and Managers, have been developing standards for use with hydrogen and very much building on existing standards that already exist. Likewise, BSI have developed something called a PAS 4444, which effectively provides guidance for how hydrogen appliances need to be tested and certified to ensure that they are safe for use in our homes of the future. And then in the large area development of the appliances, we have a number of different appliances that are being developed both for domestic use and some commercial use. And we have the likes of Baxter and Worcester Bosch developing different types of boilers for us. But we also have a number of different organisations developing gas fires and gas cookers. And whilst the work is still underway and they're developing prototypes, all the progression that we're seeing at the moment is very encouraging. And I'm sure Jeff will let you into a bit more of the insight of the progress that Baxter have been making to date. One important concept to note here in the HIFA heat programme is we focus very much on trying to make sure that the appliances that are used and everything in terms of the end use setup is similar or the same as or like for like as is the existing system. Because from a consumer point of view, this will certainly help for ease of transition. And this is critically important when it comes to thinking about how we're going to move to an energy transition future scenario, the role that consumers have to play in terms of what appliances they wish to use in their homes and how they wish to modify their homes in order to help get to net zero will be driven very much from their perspective. So having something familiar that they are able to use in a similar manner as is currently is considered to be quite an important approach aspect. And also one of the concepts that has come out of the HIFA heat programme is hydrogen ready, which is concept being that an appliance can be installed and put in place that can run on natural gas to begin with, but at the point where a conversion over to 100% hydrogen needs to happen, then the component parts of that, simplistically, component parts of that appliance can be converted so that then the appliance can run on a full 100% hydrogen. Equally part of the programme, we're developing metering. Metering is going to be important to measure the gas, so we need to have hydrogen meters to be developed as well. And we've had some interesting desktop study type work undertaken both to understand the commercial industry and industrial applications in much greater detail, and those reports are published on the HIFA heat website. Looking at the safety element of hydrogen, this is the key piece of work we're right in the midst at the moment, but making really good progress, and there don't appear to be any showstoppers at the moment, but essentially we're gathering all the evidence around experimental testing, quantitative risk assessment into a number of different areas around frequency of leaks, leak dispersion, accumulation, ignition potentials, and what that may mean in comparative with natural gas. And everything's looking very encouraging. And lastly, we're moving into beginning to think about demonstration facilities. We had great plans in place for COP26, but as you know, this has been postponed. So we're just kind of working through when we'll be able to start developing, demonstrating those prototype appliances that have been developed as part of this programme. And all of this work really and evidence is coming into position to support future community trials, which will be driven by the various different gas distribution network operators. So hopefully that's a very brief update, but I thought it would be worthwhile just taking recognition of the important role that industry and a number of different organisations have had to play in the whole collaboration approach to make this programme successful. So there is, as you can see here, there is a huge number of different organisations working on many different aspects of this programme. And this is all to provide the evidence to be able to move forward with 100% use hydrogen in the homes. So hopefully that gives you a brief update of some of the work that's being undertaken in the HIFA heat programme, and more than happy to answer questions later.
Thank you, Heidi. Yes, we will have some questions for everybody later. We'll move straight over to Jeff to hear about the hydrogen appliance situation. Jeff.
Wonderful, thank you. Good morning, everyone. Good morning, Andrew. I've got a couple of slides to help illustrate what we're working on and what we're doing at the moment. So let's get this to share. So that's there, away we go. Excellent, thank you. So my name is Jeff House. I'm Head of External Affairs for Baxter Heating UK, so I look after our regulation and policy and legislation work. Just by intro to Baxter, so we're a major UK manufacturer of heating and hot water equipment. We're also part of BDR Thermea Group, which is the global parent company, and we operate in most global marketplaces with a very strong presence in the heating and hot water sector. Hydrogen, we are very keen on. We see it as being potentially a very neat and relatively low disruption solution for consumers, which is the big interest in our point of view. It's not the complete answer for 2050. There will be a mix of technologies needed to meet the net zero target. So we're also investing heavily in heat pumps, in heat networks, but we do believe that hydrogen has very strong potential for the vast majority really of the existing housing stock that's connected to the gas grid that will be more difficult to treat because it's typically lower energy efficiency in terms of the way it's insulated and works, but also physical fit and other issues come into play. So really, just to outline why that is, we do have in the UK, other than the Netherlands, the highest penetration per capita of gas grid into homes and businesses for end use. So 84% or 22 million dwellings currently rely on natural gas today. So that not only is, you know, significant asset value in terms of the network itself and the employment, etc., that's attached to that, but it also means that we are pretty much a single vector country when it comes to heat. So trying to shift that wholesale to anything else in a massive way is systemically very, very challenging, and it brings up a number of issues around skills and supply chain, etc., etc. So a blended future, absolutely in the future, is absolutely on the cards in terms of what will happen with technology mix, but hydrogen appears to be very attractive at this point. So we at group level recognised that hydrogen has a lot of interest from a number of mainly Western and Northern European countries at the moment. So you've got the colder climates that are sort of more interested in it because you've got a larger market for heat there. And we started to actually invest in exploratory R&D work to demonstrate or to build towards a prototype appliance a few years back now. And that's resulted in effectively a world-leading demonstration in the Netherlands that was installed in 2018. So we had a working hydrogen boiler installed into a small block of apartments in Rosenberg, which is fueled by green hydrogen on site. So there's an electrolysis plant on site, and it, you know, really is a really encouraging and real cutting-edge demonstration of technology. So the UK business, we saw again the potential that some projects such as H21 from Northern Gas Networks are starting to talk about the potential for mass conversion, and we had, you know, other projects from other gas networks in the early stages of development. So we thought, great, this, you know, potentially something we need to be involved in, and could offer some really innovative ways in which to deploy some of our R&D resource and our work. So the Hive Heat program came along at exactly the right time. We were, you know, thinking about commercializing or bringing this technology across to the UK, and then you know, developing it further to fit the UK market. And this meant we needed a product which would be suitable for UK houses. So Heidi mentioned the big draw with this will be effectively low disruption, like-for-like changeover. So we had to take effectively a really early doors development prototype and then make that suitable for a typical UK boiler situation. So we tend to have boilers that are fitted into kitchen cupboards or into fairly small spaces. So we have a compact case size, wall mounted, and, you know, it has to offer certain performance in terms of efficiency and output. So effectively what we said was, great, if we can take something the size, shape and appearance of one of our current products that's on the market today, make the internal changes and the redesign aspects of that necessary to make it work on pure hydrogen, that will be a good starting place and something we can ably demonstrate within the Hive Heat program. On paper, you would think, great, that's nice and easy. You're taking an appliance and then making it compatible with hydrogen. In practice, it's been an interesting development work, but we're doing very, very well. So we'll go on to some of the findings in a second. Essentially, though, there are some key differences. So if we're talking about blended hydrogen, so the high deploy project that Tommy's talked about, the likelihood is that current appliances will be quite happy to work on that 20%, and it's not really a concern from a technical point of view there. When we move to hydrogen purity above 20% in the grid, so in this case we're looking at 100% as being this zero carbon at point of use, 2050 compatible prospect, then hydrogen at that purity does react differently to natural gas in the appliance. So it's a faster flame speed, it combusts more readily to the lower flammable limit, and there are some key differences around the way in which we go about controlling the flame. So It's a different burner design, absolutely, because the hydrogen flame has, operates and combust differently. A big key difference is flame detection. So today's natural gas boiler, you have carbon in the input fuel, and we can effectively run an electrical current over the flame. It reacts with the carbon and gives you a signal that determines you've got a safe and stable flame present. That carbon's not there with hydrogen, so the way in which we do flame detection is markedly different inside the appliance. So burner is different, the flame control platform is different, most of the gas train and that side of it is different. The hydraulic side is very much the same, because it doesn't actually get exposed to hydrogen or exposed to combustion in that regard. So outer casing, that sort of stuff, it's been adapted, but it is very, very similar. Material compatibility is one. So we do hear a lot of discussion about hydrogen embrittlement, which is something that commonly comes up when you're talking about network level infrastructure. At the sort of pressures we're working with in the domestic setting behind the meter, we'll be seeing around about 20 millibar of gas pressure. At those pressures and those lower flow rates, embrittlement doesn't necessarily embody as an issue that needs to be really sort of looked after in terms of different materials, but we do see some differences around things like seals and gaskets. So there are some different materials that we've had to deploy in terms of hydrogen compatibility there. I think another key difference as well is condensate. So the dew point temperature of hydrogen combustion is different to that of natural gas, which is great in terms of efficiency and getting some useful heat from the products. However, it does mean that we produce more condensate, so it's roughly 40% higher condensate production than that of a condensing gas boiler today. Energy itself not necessarily a problem, so we have a different way of dealing with the trap and with the disposal. One benefit with that, though, is that the condensate produced is not acidic, whereas natural gas condensing boiler condensate is mildly acidic, so you have to go through a fairly sort of controlled way of disposal. You can't go into metallic pipe, for example. That's different with hydrogen. It could possibly go into pretty much any sort of drainage or soak away without any real issue. So this is one of our prototypes actually working in our Preston lab today, with the lovely John Harkins demonstrating for us there. And as you can see from the fluid gas analyzer probe there, we're seeing, as you expect, zero CO2. There's actually no CO2 production at all, and that's the end goal. So it is net zero carbon compatible with zero carbon at point of use. So we found, we're at the position now where we have prototype products for the high heat program ready to go. We were able to meet the design intent, so it is the same size as one of our current natural gas condensing boilers, so it will readily fit into an existing house without any real issues. Weight is always a concern in terms of lift weight and handling. Again, it's very similar, so fairly low weight. And from a performance point of view, we're hitting the sort of combustion efficiencies and flow temperatures that you would expect. So again, it can be slotted into an existing UK household heating system without having to change radiators or change any of the hydraulics. Importantly, we have a combination boiler and a system boiler. So the vast majority of UK boiler cells today are combis, so you get heat and hot water from one box. Again, we've got a solution which effectively just replaces that with a hydrogen version of. So again, you don't need to find room for a hot water cylinder, which is again one of the other drawbacks that we do see with other retrofit alternatives for net zero. Hydrogen burns hotter than natural gas, so as a result of a higher flame temperature, you would expect more formation or more predominant formation of NOx. We've managed to effectively counteract that through some fairly smart design and flame handling technology, which we can't get into much detail about today. But effectively, we're seeing NOx levels way below that of our best natural gas boilers. So one of the early sort of concerns that was raised around hydrogen combustion was, what about the NOx, what about the air quality? It's actually proving to be really, really positive in that regard, and something that's, you know, massively below the London plan limits, etc. So something that won't cause a problem. There's no carbon in the fuel, therefore a big safety benefit with this, we believe, is there's no possibility to produce carbon monoxide. So when you look at industry stats around safety, you know, there's concerns around flammability and escape, but there's also a much higher prevalence of carbon monoxide, not necessarily from boilers. You know, you get incidents related to fires. Even I've seen things with diesel generators, with people running homes, etc., causing issues around carbon monoxide. But because there's no carbon monoxide potential, which in the round is a great safety benefit. Heidi mentioned hydrogen ready. So again, we have that concept well in development. The idea being, you can fit a boiler out of the box that will run on natural gas, that can be installed and commissioned by a gas safe competent engineer to the current framework, and it will quite happily run on natural gas for its entire life if needed. At the point of a local network conversion, so for example, those in the northeast and northwest might see that sooner than others, but you could potentially turn up with a network engineer or one of our engineers or a trained engineer with a small number of components, and switch the boiler over to run on pure hydrogen, recommission it in a really short interaction. We're talking in the region of 30 to 40 minutes tops. So it really is, from a conversion point of view, a huge benefit in terms of time and cost saving. And again, Heidi mentioned through Hive Heat, we're moving into the trial phase fairly shortly. Obviously, to an extent, that's been pegged back by the COVID situation, but we're hopeful we'll see that start to happen fairly quickly now. So that is essentially everything I wanted to run through, Andrew. So happy to move through to Q&A.
Thanks very much, Jeff. Well, thanks to everybody. There are a few questions coming up because I think people are fascinated to know the whole production process and the schedule. So questions around that. So feel free, whichever one of you wants to answer this when I throw them all out. Here we go. A few questions about the renewability. Renewable, is it renewable the way that you're going to produce the hydrogen? There's a few worries about that, and also the amount of energy that it might take to produce hydrogen. I guess there's no fixed yet. There's no fixed actual production strategy, is there? It's just looking at several at the moment.
Yeah.
So
I mean,
go on, Heidi, you go first.
Okay. So from that, I mean, people are entirely right. There's two main ways that hydrogen can be developed at the moment. It's either blue hydrogen, which is effectively using fossil fuels and carbon capture and storage to capture the carbon and put it back in the ground, which is blue hydrogen, or there is green hydrogen, which is effectively using renewable energies and electrolyzers to create and water to create the hydrogen. Obviously, there's a preference towards green hydrogen, and I think there's big moves in the industry that obviously that will be the end state that the energy system is aiming for. But there's got to be recognition that there's a cost associated with that green hydrogen at this moment in time. Not to say that that won't change in the future. So at this moment in time, it's considered that blue hydrogen is possibly cheaper. Now, it's a huge complex area. The government has got a number, and I'm not close to all those different programs, but there's a number of different programs underway looking at both the technologies that need to be innovated to help drive down those prices of the hydrogen, but also that will come into play in that energy transition. But one thing I think the industry and everyone's clear on as a whole, that we mustn't be creating more carbon by using fossil fuels to create the hydrogen. Yeah. But it's a hugely complex area.
Yeah, we're asking you to funnel the complexities of research into 40 minutes. So apologies for that. Welcome to our world. Tom, did you want to add anything in, Tommy?
Yeah, I think Heidi summarised it very well. Yes, there are, broadly speaking, two ways of producing hydrogen. You either reform it, or you either reform natural gas with steam and capture the carbon, or split water through electrolysis. There is a third option which isn't in production or development to any great extent at the moment, but is biohydrogen, which is effectively taking biomass and converting it fully to hydrogen and then capturing the carbon. The kind of USP, if you like, of biohydrogen is that it is a genuinely negative emissions vector. So in a net zero world, negative emissions start to become fairly important to try to counteract cows, for example. In terms of what is the likely profile of production that we're going to see here in the UK, there seems to be a general consensus that blue hydrogen will look to dominate that profile. So the CCC that was mentioned earlier, so the Committee on Climate Change, thinks that the total hydrogen opportunity is around 270 terawatt hours a year. So to put that in more tangible units, it's roughly how much, it's roughly the total electricity demand of the UK currently. And around 85% of that is looking to be produced through blue hydrogen, and about 15% through electrolysis, primarily due to the relative price of the two. But it's worth noting that the blue hydrogen, although originated from natural gas, the capture rates of today's technology are incredibly high. So so you can achieve capture of around 97% of the carbon. So granted, there's a 3% residual that would be released to the atmosphere, but as a starting bat, 97% is not bad.
Okay, now I'm going to summarise a question from about 4 people, but it's probably a question you've heard before, but I'm going to pose it. Isn't hydrogen just a big, expensive, time-consuming, fill in all of the other adjectives here, that's going to cost a lot of money on the electricity bill at the end of the day? Is it all worth it? I'm sure you've faced that before, that question, Heidi and Tommy, before. You have an answer?
Yeah, so I think it's possibly worth remembering and considering what our energy consumption is, but more importantly, what our energy profile is and where that energy is needed. So if we look at kind of Northern European climate countries, we have huge demands for heating in winter months. Primarily that demand is met by gas. So at peak times, our gas distribution network transmits something like, I think it's, I'm going to get my numbers wrong here, but 4 to 5 times the amount of energy down the gas network than we can down the electricity network. So if we want to, I mean, there's 2 extreme ends, isn't there? We could either imagine a full gas future, or we could imagine a full electric future. I think everyone, from a common sense point of view, recognises there's going to be a balance somewhere in the middle, and both still are needed. So I think it's really important to recognise that if we want to distribute or transfer that amount of energy, which we currently do down the gas network, by anything other than a type of gas, we're going to have some huge challenges in terms of building the infrastructure required to transmit that energy down something like electricity grid. So I think there is wide industry acceptance that there has to be a gas solution as well as electric solution. And I always quite like to think of it in a manner that we're trying to transition into a future where in the past we've had relative independence between gas and electricity, but we're moving to a more fully integrated situation where both have really integrated electrochemical future, if you like, that has an important position to play, and that relationship between them both is important. And the hydrogen can work through generating electricity as well as using it for end use for heating. So it's useful from that perspective.
Thank you. Yes, you clearly have answered that question before, Heidi. We've got 3 minutes left. It rushes by, doesn't it? So I'm going to fire off a quick technical question, which I'm imagining is for Jeff. Twofold. You like the second one. The first one is, can they deliver peak output at low flow temperatures of 50 to 55? And if they can't, how much bigger are these boilers going to be?
Oh, we absolutely can. So same as with today's natural gas boilers, really, they actually operate more efficiently the lower the temperature goes, because you're then down below the condensing dew point for more of the time, etc. The product will be sized from the outset to fit into that compact box and be able to operate quite happily, either at higher temperatures where it's needed in older, draftier homes. I mean, the likelihood is that we'll see energy efficient intervention and insulation. You wouldn't necessarily just go and put in, you know, a changeover to a different energy vector and leave the house alone. We need to insulate as well as part of the overall goal. But yeah, absolutely, it will work quite happily in the same case size, in the same dimension at lower temperatures.
Okay, and then the follow-up is, can you use hydrogen to run a heat pump?
Well, we have in the past, in the commercial market especially, sold gas-fired heat pumps or gas-driven heat pumps, so it runs on an absorption cycle. The burner technology that we've effectively cracked, which is the difficult bit, the flame supervision and the burner, that could be transferable to other platforms, so there's no reason why we couldn't have an absorption-driven heat pump in the future.
Okay, good. And then I think we just end with what is probably the million-dollar question, which is particularly with COVID knocking schedules a bit, when are we going to see hydrogen? That's probably a three-part answer, isn't it? Who wants to give the three-part answer? What are the schedules now, and how has COVID presumably knocked that by a year at least?
So it's interesting that COVID on the hydrogen side has probably had less impact than people think. Generally speaking, the big hydrogen programs in the UK are all government funded by some means, and people can complain about the government, but once they've committed to funding something, it happens. And if the money has already been, if the contracts are signed, then the programs carry on. And so we haven't had the uncertainty that probably a lot of the purely private ventures have had around having to balance, cash flow versus R&D. So in that sense, there's been less impact on the hydrogen industry than I think people would probably think. And there's a lot of inertia around hydrogen. It's a big moving train, and so it's going to take a lot to stop it.
Okay.
In terms of the macro picture, as mentioned earlier, the earliest bulk hydrogen production is looking to come online 2025. So that's just over 4 years away is when we'll start to see sort of major parts of the country having a blend provided to them. So the HyNet program that I mentioned earlier is looking to provide a blend of hydrogen to around 2 million homes across the Manchester and Liverpool region. And then along that kind of timescale will be trials of 100% hydrogen that start to get operated, and it's likely that full conversion would start somewhere in the would start early 2030s. But Heidi has probably got a position on that to share.
Yeah, so I just probably looking at it from slightly more small scale practical steps. Obviously on the Hyper Heat program, as soon as we've got all our prototypes, and you can see Baxter have already developed their prototype, we're looking at where we can demonstrate those in a movable facility, which is primarily set up to demonstrate at COP26, but possibly there may be some demonstrations earlier than that. We're trying to work through the plans of exactly what that will look like. With regards to moving, obviously, but also from the point of view, hydrogen is already being demonstrated at the moment. The High Deploy project is happening. High Deploy phase 2 project, next trial is happening as well. There's also organisations like SGN, Gas Distribution Network Operator, that's just put a bid into Ofgem to go to the first 100% hydrogen community trial that I believe the timescales they're looking at is 2022 starting. So there's lots of small trial type projects beginning to happen now. And then what Tommy's mentioning is when those decisions and when we might start to be able to see full scale conversion happening. But I think one thing for us all to remember is it's only 30 years away until 2050, which is really not much time left at all. So we definitely need to get these small demonstrations off the ground and trials as soon as possible to build the confidence needed in order to move to wider scale rollout, whatever that balance is between electric grid and the gas grid.
Thank you. I'm now getting frantic text messages from my organisers saying I've got to wrap it up. So we'll end in traditional fashion with, do you want to give us one sentence each, which is your one takeaway from your session today for the audience? Jeff can go first.
Go on then. Yeah, so from a technology point of view, we're confident that we're ready. We've got working prototypes that are on the cusp of being able to, we'll be ready to commercialise, and it's, behind the meter, if you like, we're ready to go.
Great. Tommy?
I'd say I would really build upon Jeff's statement to say, in general, the hydrogen industry has done quite an incredible amount of work over the last couple of years to get ready to actually deploy. What's needed is government policy to support that, but by and large, in terms of a technical side of things, we know how to safely distribute and use hydrogen. It's now a case of having the government provide the necessary support to be able to actually start this in earnest.
Thanks. And Heidi?
I would agree with all that both Jeff and Tommy have said. One thing I would add to it is that, as we've seen in programs like High4Heat, the collaboration between the different organisations is really important for driving the innovation and driving costs down. The High4Heat programs try to make things as open and transparent as possible and encourage industry to work together, to share ideas, and encourage that general broader learning and understanding of how energy transition can happen. So I would just encourage everyone to be open-minded and share their knowledge as widely as they possibly can, because in doing that, we can show, and we've demonstrated by the High4Heat program, that things can progress forwards very quickly if we put our heads together and our creative talents together.
Brilliant. Thank you very much, Heidi. Well, thank you to everybody. I think what we'll try and do is, when we do the write-up of all this, we'll put some of the links to the high deploys and the High4Heats and that sort of thing, and link in. Now, I am prompted, because he's just appeared in front of me, that we are running 6 minutes late. But don't worry, Matthew, you carry on with the schedule, and I will organise making up the time at the end in traditional chairman's fashion. But I'm delighted to welcome Matthew Trewella back to our stage to tell us about the technology progress in ground source heat pumps.
Good afternoon.
Yeah, the floor is yours, and I will bow out. Thank you, Matthew.
Good afternoon. Thank you, Andrew. Share this to the screen, a few slides. A very interesting debate on hydrogen there, and one of the things we're going to look at today is how to integrate hydrogen with heat pumps, actually, so it picks up on some of the themes you were just talking about. It's a very interesting time for heating at the moment, because one thing is for sure is our heating in 30 years' time is not going to be the same as it is right now. And everybody is looking at the best ways and all the different possible ways to get to that future. And it's fair to say the politest way of describing it is a debate. Occasionally it's not that friendly. And you have things like, should we go district heating? Should it be an individual? If you like district heating, should it be third, fourth or fifth generation? If you think it should be electrified heating or some form of green gas. If you like electrified, then is it resistance heating, or is it one of the various types of heat pumps? If you decide you like heat pumps, then you've got to choose between air source and ground source. If you like green gas, you've got to choose between hydrogen and biomethane. And all of these have various strengths and weaknesses. One thing that we would contend is you are going to need all of it in some way, shape or form. And we're going to look at a possible way that most or all of these technologies can actually be unified into one concept. So the concept that we'd like to introduce and chat about is, a little quick summary there of the arguments. Please don't take this as a comprehensive list of all of the arguments for strengths and weaknesses. And I'm sure everybody listening will disagree with at least one of those. And if I'm honest, I don't agree with all of them as well, but that's a flavour of the types of arguments, stroke debates that are going on right now. If we just look at hydrogen and ground source, for instance, to get it's relevant to what we're going to talk about in a mo. Ground source is excellent at making the best of electricity generating sources, in particular renewable electricity. So for every unit of renewable electricity that's produced, you get to leverage another 2 or 3 units of heat out of the ground, so that you really maximize all of that efficiency and therefore lower the cost, both for building the electricity generating capability and for the cost of purchasing it. Hydrogen, you don't get quite as much bang for your buck if you decide to make your hydrogen using renewable electricity. By the time you've created it, stored it, transported it, and then burnt it in a boiler, then you get 50 to 60% of the energy. So on that sense, it's less efficient. On the plus side, it's very, very flexible. So once you've created it, you can store it, you can leave it there, you can decide to use it whenever and wherever you like. So it's very flexible in that regard. And the system we're going to look at now combines best of both of those things. So the foundation for this is a type of district heating. It's called an ambient temperature network, and for heating and cooling. What that looks like is a series of pipes running around your district, town, city, streets, connecting every property together, and that circulates a working fluid that ranges between 0 and 20 Celsius. And the ambient temperature is similar to the ground that it's circulating in. You then have a heat pump in each property that either upgrades that energy to produce space heating and domestic hot water, or chills it down to produce cooling. And you can take passive and active cooling from the same network. So there are some cooling applications where the network's already at the right temperature and you can use it directly without a heat pump. And more intensive operations, you use a heat pump, take the cold out of it and put the heat back in. Nice thing about this sort of network is all the waste products, i.e. when you're making heat from the network, your waste product is cold, and when you're producing cooling, your waste product is heat, go back into the network and recirculate it around to act as a source for the other devices. In theory, if you had a perfect world and perfectly balanced heating and cooling needs, then that's all you need. In practice, they never balance, and even if they balance in a year, you need them at different times of year. So you then have a mechanism for bringing your temperature back to ambient, either because you've put too much heat into it for your cooling loads and you need to bring it back down again, or you've taken too much heat out of it and you need to recharge the temperature. The most common of these is a shared ground loop array, which is a series of vertical boreholes connected together that extract either heat or cool from the bedrock to bring that temperature back. The bedrock in the UK sits around 10 or 12 Celsius, so it's right in the middle of our 0 to 20 Celsius ambient loop. So whatever you've done to it, made it warmer or cooler, your closed loop boreholes can bring it back to that ambient. Other ways you can do that, you can access water that's stored underneath the ground in aquifers. We've just completed a project in Sunderland doing this for heating 7 tower blocks, and that's with Gen 2 housing and energy. So that's a lot of our cities, luckily enough, have nice water supplies underneath them. And particularly anywhere you find a brewery, you'll find a great aquifer. You can take heat or cool from flooded mine workings. And at first glance, that seems a little bit niche. But then when you realise that 28% of UK properties sit above coal workings, you realise that it's got a lot more potential than some people think. And you can take heat from surface water, so whether you're lucky enough to live next to the sea, a river or a lake, you can use that as an energy source, again, either for heat or cool. Running at ambient temperatures allows you to take best advantage of all sorts of sources of waste heat, whether that's underground stations, cooling a data center or a supermarket, or even a project we're working on, cooling PV panels to improve their efficiency and take the excess heat into the network to reduce the amount of electrical energy that heat pumps need and the efficiency and therefore the strain on the grid. How this ties in with the electricity grid, the heat pumps are powered from the general electric supply and we recommend that they're fitted behind the meter. In other words, if somebody wants to crank the thermostat right up and have their building really, really warm, then they'll increase their electricity supply for the heat pump running and taking heat from that ambient temperature loop. You can also install smart controls, and we're working on these projects to automatically load shift to times when the grid can most accommodate it, helps balance the grid, but it also, electricity is cheaper at those times, so it reduces the running cost to the occupants. And you can do that over timescales of an hour or two, just using the fabric of the building, but installing some local thermal storage, which could be water, but more likely with phase change heat batteries, the sun type approach, you can store for 24 to 48 hours. So you can use that renewable electricity, even though the generation is variable and your demand is varying. You can handle that on those sort of timescales. A lot of people will say that it is impossible to electrify heat, in inverted commas, because the demand for gas, as shown in the red line on that graph, is many times, sorry, the demand for heat is many times larger than the peak electric supply. But there are other ways to analyse that, and Watson et al. Have redone those calculations. That you then add in the efficiency of the heat pump, and then also add in automated load shifting and smart controls. What you'll find is we'll need to generate around 60 to 80% of the current peak electricity supply to power all of these heat pumps. Now that's a fair challenge, but it's nowhere near as difficult as a lot of people think it is. We think it's perfectly possible to do. Other ways you can reduce the strain on the grid and reduce the strain on the network is using batteries, in particular, as we've shown there, utility scale batteries that stabilize the grid for our whole local areas, again on that 24 to 48 hour timescales. And then if you integrate smart charging of things like electric vehicles with the smart control of the heat pump, so you've got the whole system understanding of what energy is going and where, then you can get even further local grid balancing. Finally, there are going to be times when the renewable generation or electricity generation isn't going to be able to keep up with the demand on the grid. And as we just heard earlier, you can turn hydrogen into electricity, either with a CHP unit or with a fuel cell. If you prefer green gas, biogas, you can convert that to electricity using a CHP machine again. And our concept is that high value hydrogen that we've produced, that's the best time to use that is when you really need it, and you can boost the electricity supply into your local area by converting that hydrogen into energy. One thing that happens when you do that is you produce waste heat, and with our concept, that waste heat is also picked up and put into the local area grid, so that feeds energy into the ambient loop, and that has the lovely benefit that you reduce the demand on the grid. Either heat pumps need less energy because they're running at a warmer temperature at the same time as you're feeding energy into the grid, and you get a nice double benefit there. How should we do this and where? Well, our contention, our concept is you draw up a list in the country of where to start, and that could be based on several factors, including which areas have the best geology, who has the worst air pollution. So if you decarbonise both heating and transport, then you also solve the air quality issues. Air quality is mostly dominated by transport, but a fair fraction of it is from heating as well. So we think you should start in those areas that have got the worst air pollution right now. Also where local authorities are more committed, so if you declare climate emergencies, and in particular, if those climate emergencies have set net zero targets that are earlier than the national target of 2050, that would be a good place to start. Rolling these out. And then lastly, where you've got a significant cooling demand. So if you've got a data center, a supermarket, or you've got process cooling, you can reduce the capital cost of putting the network in, because you don't need so many boreholes, for instance, to recharge the network. And you can increase the efficiency of the heat pumps because they're starting with a warmer temperature. How much will all this cost? Quite a wide range there of between 8 and 30 billion pounds, and that will per year to decarbonise 100% of heating in domestic properties by 2050. And that depends a little bit on when you start and how much advantage you can take of the different sources of waste heat. Compare that to our overall government spending last year from the Office of Budget Responsibility, and you can see last year we spent £40 billion on servicing a debt, and you can see that the amount to fully decarbonise heat using this method would be between 1 and 3%. It's also interesting to note that air quality issues alone are estimated to cost the UK economy £20 billion per year. So my background's astronomy and astrophysics, and I'm used to jumping from really tiny numbers to really big numbers and back again. But even when I see 8 to 30 billion pounds a year, it seems like a big number. But when you put it in context, actually, it's not ridiculous to completely decarbonise, and that's every single property in the UK. In summary, then, we have the technology available right now, and we could combine the best features of various types of renewable generation, smart control and heat pumps, and hydrogen into an integrated system that will take us on into the 21st century. To achieve that, we are going to need coordination. All of those devices are going to need to talk together to each other in a common language and understand when to turn on and off to stabilise the grid and best balance. And we're also going to need significant support from government at all its levels, from national through to regional and very local on the parish scale. So that's the idea and the concept, and that's one way we think we can make big progress towards our net zero 2050 targets. Thank you.
Thank you, Matthew. So lots of interesting things there to get our teeth into. We've now got a short video coming up, and just for the benefit of the panelists who are just arriving, we are running 5 minutes late. 5 minutes late. So Sophie is going to queue up a video for us, and after that I'll pop back on and we'll have the next session with delving into detail with the heat pump guys. Thanks.
The foundation for this vision is a type of district heating called an ambient temperature loop. This consists of a series of pipes in the ground that deliver a working fluid, typically between 0 and 20 Celsius, to every property, domestic and commercial. Connected to this network are heat pumps that upgrade the temperature you need for heating purposes and hot water, and downgrade it, chill it, for air conditioning and cooling purposes. All of the waste heat produced by cooling goes back into the ambient temperature loop, and all of the cold that's produced as a byproduct of heating for homes and hot water also goes into the loop. That allows you to recycle the energy rather than waste it out to atmosphere. The efficiencies of both systems, both heating and cooling, are improved, and you can also store energy in this loop between heating and cooling applications. In theory, the ambient temperature loop could provide all of the heating and all of the cooling demands. But that's only true if the heating and the cooling demands are balanced to each other. Often they're not in the real world, and particularly cooling is required a lot more in the summer and heating is required a lot more in the winter. So to balance these two effects and spread out the seasonality, we use something called a shared ground loop array, which is a series of boreholes buried into the ground, anything from 100 to 250 meters deep, that recharge either heat or cold into that ambient network loop and keep it at that nice stable midpoint of temperature that you can then extract heating and cooling from. Other ways to recharge heat or cold into this ambient temperature loop are aquifers, that's water stored underneath the ground, surface water like the sea, lakes or rivers, mine water, or waste heat such as cooling the underground stations or data centres. The heat pumps are powered by electricity, and this will undoubtedly mean more investment in low carbon electricity generation for our grid, things like PV and wind in particular, but potentially also nuclear, tidal and hydropower. These electricity power sources are more intermittent, and our heat pump controls will be smart enough to account for this, turning heat pumps up when electricity is plentiful and moving it to times when the grid can most accommodate it. We'll also combine with local storage, so storing heat in properties, ready to provide heating and hot water when required, generating and recharging that heat when electricity is most plentiful, when the grid can most support it. We see integrating these controls with a similar control mechanism for electric vehicles. So vehicles are charging at the same time as the grid can accommodate it best, and all of these systems are working in synchrony with each other. To help with this, we see grid-connected batteries, probably large centralised batteries, helping to stabilise the grid and to smooth out the intermittent nature of the generation and the demand. We also see a role for hydrogen. One of the ways you could do it with an ambient temperature loop is you could connect a hydrogen-powered fuel cell. So when the local grid comes under strain, the fuel cell fires up, delivers electricity into the grid. It also, the waste heat that comes out of the fuel cell is delivered into the ambient temperature loop, which improves the efficiency of the heat pumps, reduces the electrical demand at the same time as the fuel cells are inputting electricity into the grid.
Some interesting sound editing at the end there, faded out with a jump cut. So without further ado, we move from ground source heat pump technology to a wider discussion of the technology around heat pumps. And I am delighted to be joined by three experts in the heat pump field. We've got Graham Wright, we've got John Felgate, and we've got Dave Pearson. Now, each of them noted for their ability to speak, sometimes at length, on the subject of the technology, but it's the experts you want to hear from. So what I'm going to do is ask them in turn, a bit like with the hydrogen one, to delve into their area of expertise. And the only thing I haven't done is told them who's going to go first. So I'm going to put Graham on first. That's all right. So yeah, we'll just have you giving your perspective on. We've heard a lot about the numbers around heat pumps today, and I know that you have some views on how we're going to deliver them. And then we'll move to John and then to Dave, if that's all right. And then we'll all get together to hear what the audience want to know. So over to you, Graham. Everybody else, if they want to go on off video for a sec, and we'll go from there.
Thanks, Andrew. Good afternoon, everyone. I was listening to some of the presentations about hydrogen and also listened to the last presentation, and there's a lot being said about what technology is best, and actually really they're all pretty good. We just need to find the right mix, and the right mix is actually probably based around leveling the playing field for all types of heating system that's going to be used in the future. I mean, I do agree by 2030 or 2050 you won't recognize heating devices in people's homes. They will be something completely different from what we currently understand now. There are some things we need to get right though, and they are the basics in my mind, and especially around the demand for electricity, and again that was mentioned in hydrogen. We need to reduce the demand wherever we can, and there's a fundamental that we don't really understand people's heating flows in buildings. And I'm not criticising people here, we've just been putting in boilers based around what we think people's hot water demand is and saying they'll do your heating as well. So your average boiler is probably has got a capacity of 25 to 30 kilowatts in terms of output, but in many respects it doesn't need to be anywhere near that size. So one of the first things we need to do is to understand what the output or the heating load in everyone's boiler is going to be, and the hot water demand. And then we need this kind of surge. I'm calling it a surge in energy efficiency. We need to make the most of what we got. It was also mentioned in the last set of presentations, we haven't got much time until 2050. It won't surprise anyone, there are only 7,400 working days until 2050. So we've got to get on and start doing this now. And we've got to have 80% of the homes, obviously in the UK, by that time, and near enough zero carbon. So, I mean, it's going to be quite a challenge, with the others taking mitigation wherever they can. I think the Green Homes Grant is a good start. But it needs to ensure quality. I think one of the issues that we've kind of got at the moment is we're going to get a lot. I'm kind of concerned about the quality. Then we've got other grants that are coming in the future, so we need to be careful about how that's going. And we also need to ensure that the Conservative government actually comes in with that £9 billion promise for the needs that we're going for the investment that we need to put in place. there's another way that we can also look at this. We need to shift the demand away from the peak. We all look at peak loads coming in, people switching their heating systems on and off. And as far as I'm concerned, you know, that needs to be moved away. We need to think about constant heating within buildings, which I know sounds counterintuitive, but we know that the heating devices that we're looking at in terms of heat pumps and other devices work far better with a constant load and far more efficiently rather than switching them on and off when you need them. And there are several ways we can look at that. I mean, if you look at Octopus Energy, they've come up with specific tariffs. They're looking at taking a tariff away from about 15 pence per kilowatt hour and dropping that back down to 9.7 by shifting the demand and shifting the way that people are using electricity, specifically with heat pumps. Something that gets spoken about at length, and something that I don't think we've really got our heads around at the moment, is how to integrate smart controls in everything we do. Because if you look at the house of the future, it could well have PV panels, it will have an EV vehicle of some sort, have some kind of battery storage and heating device, and we need to be able to integrate those. There are some very good examples around of how I think that's being done at this particular point in time, but we need to make it mass market. And I kind of think both those points marry up together. And the third point is, and I think it's fairly clear, and again, I don't want to look not one particular technology, but if you've got a choice between a heat pump and direct electric, the choice has got to be a heat pump because it's far better in terms of efficiency. I think that kind of sets out the three areas that I want to pick up in this particular section.
Thanks, Graham. And that segues neatly into John, who's going to talk a little bit about the electric grid as well, I think. John.
Yes, good afternoon, everyone. I'll just start my video. There we go. So I hope everyone is safe and well. I'd like to spend 4 or 5 minutes just speaking about heat pumps and the electrification of heat. By that, I mean using electricity to provide space heating and domestic hot water production to our homes and businesses. I believe that electrification of heat has a big role to play in the not too distant future. Heat is the largest energy consumer in the UK, more than transport, surprisingly. So we have to do something to reduce greenhouse gas emissions from this sector, from our sector actually, that's the sector that we are responsible for. And I'd love to hear comments about that and about the challenges we face in making it happen. But first, I'd like to set the scene by describing a hopefully relevant art installation that a local artist, Richard Box, created just off the M4 at Junction 18 some years ago now. He planted hundreds of fluorescent tubes, the ones you see in overhead lighting in offices, in a farmer's field where the electric lines came quite close to the ground. And the magic thing is they glow at night. And it highlights the fact that electricity loses energy as it's transported from the point of manufacture, the power station, and where it's used in our homes and businesses. And for this reason, electricity was always considered to be a dirty fuel, when I first joined the industry. And the knock-on effect was that the building regs at the time did not look favourably on electricity as an alternative to mains gas for providing heating and hot water. However, future's bright. The way we create electricity has changed since then. Renewable energy now plays a big part, offshore wind and PV, etc. So now electricity is considered to be a much cleaner alternative to fossil fuels, and the building regulations have now changed and do now look favourably on electricity. In fact, I'd go a step further and say that electricity is the only fuel that can be created sustainably. So our focus has to be on electrically powered products, no fossil fuels. Leave it in the ground, don't use fossil fuels. But one of the key challenges for any country, I think, transitioning from to renewable energy and away from fossil fuels is matching the supply with demand. And this is where heat pumps come in. So imagine trying to heat all our buildings with direct acting electric panel heaters. You know, the electric draw on the power grid would be enormous. However, because heat pumps harvest a proportion of the energy they provide from the environment, they offer a very efficient way, a really efficient way of electrifying heat. But we still need to be careful about how we deploy heat pumps in large volumes in the UK. This is a bit that worries me. If we get it wrong, then we end up with flickering lights and even power cuts or power outages. So we have to work closely with the energy providers and the network operators to ensure that that doesn't happen. Don't want to give it a bad name. Also, and this is from a manufacturer's point of view, the design of the products and the systems we supply as an industry have to be smart. We have to do everything we can to reduce the demand on the electric grid during times of peak demand. So, for example, we could program our heat pumps to heat hot water in storage tanks during times when the demand for electricity is low. I read somewhere that there are 11 million hot water tanks in our homes, and they could all be used like a kind of battery to store energy and shift the load from one time of day to another. And if we get really smart, we could use those tanks during times when there's excess energy, you know, windy days, for example, when the wind turbines are spinning nicely. Another option would be to switch heat pumps off. It's a bit controversial, that one, but switch them off, or maybe down a little bit for a period of time. I'd suggest that in most houses you could put up with that for a short period of time, especially if you were financially incentivized to do so with smart heat pump tariffs. Grid storage could also help, storing energy in batteries near the point of use. However, I should temper all this techie stuff with the fact that product design has to be as plug and play as possible and readily available. I think at the moment, most heating systems are sold as what I would call a distressed purchase. Your fossil fuel boiler is broken and you need a new one right now. And actually, that is possible. Our industry is completely geared up to supply a replacement fast. The merchant in the local town stocks the product you need. There are several qualified installers within a stone's throw of your house who can fit it. But that's not yet the case with heat pumps. Normally, you would have to make more room in your house for a heat pump. And you'd probably have to apply for permission before connecting it to the electric grid, which takes a bit of time. You may even require planning permission. And most likely at the moment, there are a limited number of qualified installers in your area. So it's not yet easy to roll out heat pump technology in large volumes. We've got a bit of work to do there, including a lot of training. So to summarize, manufacturers have some work to do to make products easy to install and difficult to install badly. And also they need to be smart enough to help with the grid capacity issues I mentioned earlier. We don't need the flickering lights and the power outages. We need to train more installers and make heat pumps or installing heat pumps financially attractive to them. That's key for driving the industry. There's got to be a good business plan there. I think we should also explore offering heat as a service. This lends itself well to district heating systems and multi-occupancy buildings, city centre living is the buzzword. Instead of owning your own boiler, you simply buy heat from a central supply. And that helps to address some of the cost and space requirements and the issues I described earlier. So I think that's enough from me. We've got a lot to do here, but I look forward to the future, and I'll pass the ball back to Andrew now.
Thanks, John. Plenty of food for thought there, so plenty to discuss. Now, I think ramping the scale up a little on the heat pump side, careful what I'm saying there, will be Dave telling us about big heat pumps and other things.
Thanks, Andrew, and thanks to the other speakers. Food for thought indeed. And I'll start with an analogy. And we're effectively in the UK, and this is a very UK perspective, but we're effectively running a Weight Watchers meeting and giving out donuts at the front door, or an Alcoholic Anonymous meeting and giving out gin and tonics at half time. That's the way that our government is behaving, in the sense that we are still giving people free and ready access to what essentially the problem is, which is gas. I've been in the heat pump area for about 12 years. And one of the things I first realized was that it's very complicated, because there really are heat pumps for pretty much most applications. And people will say, oh, heat pumps don't work for older houses as well. And they're probably right to a certain extent, but equally gas boilers don't work as well for older houses that are very drafty. So drawing on some of the previous comments, it's really about thinking what the challenge is. So the first way I split the market up in my head was old buildings versus new buildings, and small buildings versus big buildings. And the bit that we are specifically focused on is fixing the existing stuff. So anything that's already built, and in particular anything that's larger, is the segment. So city centres and bringing district heating into city centres. And the market's evolved so much since we first got involved that previously district heating associations wouldn't really contemplate heat pumps, because heat pumps were small boxes that went outside somebody's back door. So the whole thing's evolved quite a long way, but what hasn't evolved is the support mechanism, which is actually really quite sad, because it's going backwards. When I first came into this, there was the Renewable Heat Incentive, which is the UK government's adaptation of the European Union's Renewable Energy Systems Directive, that basically says you will get to a certain percentage of renewables, in particular heat, by a certain period. The UK government took a very bold step and went ahead of the rest of Europe and applied the Renewable Heat Incentive long before any of the other countries really started doing anything. And we stole a march in the world, frankly. However, there were two mistakes in it, and I'm not going to dwell on the domestic bit too much, but John mentioned at the very end there about business models. It wasn't permitted for a third party to receive the domestic renewable heat incentive until 2018. So we had this big carrot dangling in front of us, but the brakes were fully on. The donkey was shackled to the fence. In the non-domestic market, we had a similar situation where, although biomass, for example, you could apply for a pre-accreditation or a tariff guarantee and then build your project with that, knowing in absolute certainty you would receive the incentive that balances the financial gap. That wasn't permitted for large renewable heat pump projects until the summer of 2018. So again, we've got this rather sterile carrot that's not doing anything. And so now that these two things have been fixed, then the RHI comes to an end. And we've got a situation where homeowners are basically, some genius somewhere has done some analysis and said, the problem is the upfront costs. What we'll do is take an operational support mechanism, so the RHI, which essentially pays back the cost of buying the heat pump, whether it's small or large, over either a 7 or a 20-year period, depending on if it's domestic or non-domestic. Instead of giving you 100% grant over that period, we'll give you, in the case of domestic products, a £4,000 grant up front for a system that probably costs in excess of £10,000, possibly even higher. The heat pump I put in my house was between £20,000 and £30,000. There is not a chance in the world, even as a heat pump geek, I would have put a £20,000 heat pump in my house. My house is now gas free, so I'm very pleased about that. There's no way I would have done that with that sort of small upfront piece. However, if the government had said, you will not install another gas boiler in your house, I would have had to do it. So we're lurching from this situation where we've had a sterile carrot and no stick, to a situation where we've now really not got a carrot at all. It was dangled in front of us and then it vanished. And we've still not got a stick, because nobody is saying to the market, and specifically in the case of the non-domestic segment and district heating, nobody is saying you will decarbonise your building, you will stop creating all this air pollution that Matt talked about in the £20 billion a year. So it's absolutely fine to come along to your Weight Watchers meeting and eat donuts in front of everybody and don't bother doing anything. And that's a very sad state of affairs, because it's actually going backwards. not forwards. And despite all the chat about green heat network deals and things like that, from what I'm picking up on it, it's essentially saying we might give you a little bit of support mechanism, but we're going to leave the status quo on the table. And so long as that exists, I don't think there's going to be a market. So that's my sort of opening piece of, this is not about technology. It's not about finance. There's more money you could shake a stick at in terms of wanting to invest in things. It's about policy. And those that are writing the policy, frankly, should be ashamed of themselves for taking us backwards when we were in a leading position in the race.
That's it. You've ended on your polemic there, Dave, have you? Right. When everybody like to join in, back on your videos again, and we'll try and unpick some of these big areas that we've talked about. So for you, Dave, it's the key thing is that incentive piece. Is that what's going to stimulate?
No, I don't want a market where there's incentives. I want a market where we're comparing options that are compatible with the sort of society we want to live in, i.e. clean, locally clean in terms of NOx and globally clean in terms of CO2. I think if you try and compare heat pumps of any shape or size to subsidised gas in a situation where the price of electricity, the spark gap, in the 12 years I've been involved has gone from about 3 times the cost of gas to about 5.5 times the cost of gas. You've got no chance. So whoever is looking at this, they're setting the market up to fail. Meanwhile, we're being told, just wait for hydrogen, that'll come along. Even if hydrogen does come along, simple physics tells you it will be between 20 and 30% as efficient in terms of the use of offshore electricity in terms of heating a house. Only a complete moron would back that for heating domestic properties. It's just a really bad bet. And if they came out with some honesty and said, yes, hydrogen is a solution, but by the way, it will be about 8 pence per kilowatt hour, which is about 4 times the cost of gas, then we might actually have a bit of honesty about it. But we've not. We've got a bunch of, whoever they are, twisting arms and ears of government, basically lying to them that this is a viable option. It's not.
Just reflecting, this could have been a very different conference if you'd started at the beginning and then had them all tearing in at you afterwards. So let's think about, I'm trying to turn this into a positive, Dave. Let's think about the numbers game. So we've heard some big numbers are required in heat pumps to, if we're going to reach that net zero. We've got manufacturers represented here and associations. Is it realistic? I mean, to some extent, I think people on the boiler side think, well, those heat pump guys, it's bonanza time for them. What's the view from your side, John or Graham?
If I may, I think the heat pump document last year clearly stated 1 million heat pumps a year by 2030. That's what we need to be. That values the market at about £5 billion annually. So I mean, and that's just when you start to look at where we are now and where we are going to be in the future, it's a massive jump. We also stated in that document that there are 3 things you need to do. One is we need to fix a lot of what Dave was saying. All right, perhaps I wouldn't be quite as forthright, but there was a hell of a lot in there that I agreed with. The spark difference between fuel is absolutely one that needs to be done, but you've got to be careful. You don't want to push people into fuel poverty. But on the other hand, you've got to incentivize them to make it happen. You need to be able to ensure that government policy lines up. I mean, if you look at building regulations as they currently stand, it's a complete nightmare. And if anything, it opposes anything to do with electrified heating, specifically heat pumps, because there's several things we have to jump over. The RHI, yeah. But in fact, homeowners prefer a lump sum up front rather than getting their money over 7 years. I can't help that one. I'd much rather get my money over 7 years for the whole thing rather than get probably a third, perhaps a quarter of what the cost would be. So in that respect, you kind of sort of stuck. And then the last one was manufacturing capacity. We're looking at 1 million heat pumps a year in the UK. Believe you me, we make a hell of a lot of condensing units globally. The manufacturing piece, I'm not saying it's done, it's actually probably the easiest thing to get done because what you need to do and what government is, it looks like they're lining up to do, is actually level the playing field, incentivise the manufacturers to plant a few factories in the UK to make heat pumps, and that will then get us going. By end of this decade, we need to be installing something in the region of 500,000 to 600,000 heat pumps, 300,000 heat pumps by 2025. Now, we need to be on the road like now. And I don't want to mention training because I know that was probably discussed earlier, but I mean, that's another area that needs to happen. So in essence, you know, let's stop looking at ourselves. Let's get on with it. And we are where we are. But people talking about COVID delaying things. Again, I don't think that has. I've been in more meetings with government just recently than I've ever been before. So I think if anything, it's probably helped.
John, what do you think?
Yeah, just to put in my 2 pennies worth, I think to make it happen, we will need a carrot and a stick approach. New build, I know that's a small part of the pie really, but that should be tackled by legislation changes. You know, that's the stick really. Retrofit should be a financial incentive scheme and should focus on reducing the need for heat first. People coin the phrase fabric first. I agree with that to a point, but I also take Dave's point. You can heat any building with a heat pump. You know, even a big castle, you can do it. It's just kilowatts. But yes, fabric first is the way to go to reduce the amount of energy that our housing stock consumes, and the incentive scheme should reflect that. I mean, overall, there's what is there? A couple of 100,000 heat pumps installed in the UK. I think that's less than 1% of the heating systems. So big long way to go. And I think electric cars have overtaken that in the relatively short time they've been at it. I also take Dave's point. Actually, I agree with a lot of what David said, but I think there's over 50,000 heat pumps were installed under the RHI scheme domestically. RHI, and incentive schemes do work, but they don't have to cause peaks and troughs. You know, sometimes I just yearn for that kind of stability from government. You know, that stop chopping and changing. Just give us clear direction, clear messaging, and let us get on with it. And we'll tackle the training issues. If it's financially attractive for installers to install heat pumps apart from fossil fuel boilers, they will go for it. The market will respond, and they'll pick up their feet and get on with it. And just my last point, really, just to go back to the product. The simpler we can make that, the more plug and play, the better. Getting the production lines running and producing the volume, I don't see as being a particular issue. Really, that's the easy part. Yeah, as Graham said.
Interestingly, the audience are coming back and saying, in essence, well, what do we need? What do you want from us? What do we need now to get on with this? You know, to move from here to getting heat. You know, there's a feeling that the government are backing heat pumps. I know the guys on the hydrogen side might disagree, but there's definite. I've never seen. I mean, Dave and I go back quite a long way on the heat pump side. I've never seen as many mentions in government documents of heat pumps as in the last year. How does the industry make things happen? I guess is how I'd summarise what people are saying. They're saying, you know, is there a route map like we saw for the hydrogen research? Is there a sort of, we want to move from here to here in heat pumps?
There was. That's the sad thing. There was an incentive mechanism. It wasn't perfect. I'd be the first to say that. It didn't allow the use of waste heat. Was right from the beginning, and that was a Brussels thing. It then had the two problems that I mentioned, and they were then fixed, but then the scheme ended. The underlying problem was it was all carrot and no stick. There was, apart from new build, and I completely get John's point, and I totally agree with it, and I think it's one of these just do it moments. Brand new house, put a heat pump in, don't put gas in it. So right, that's that quarter of the segment solved. It's not a quarter by size, but by building type. Just do it. It's the other bits though. It's the 80% of buildings that are using gas that will still exist in 2050. That's the bit we need to solve. if we built all the new buildings between now and 2050 with no heating demand whatsoever, because they're so wrapped up in you know, the absolute best of the best and better, you still will have achieved practically nothing in terms of the grand decarbonisation thing. And that's the whole purpose of this. This isn't about providing more heat pumps or doing anything else. It's about solving our climate change challenge, which the single largest contributor is the burning of gas for existing buildings in the UK. It's not transport, it's not food, it's not aircraft, it's the burning of gas in existing buildings. So we have to start focusing on the big bit of the challenge, not pissing around the edges of the other bits. And we can't even do that bit right. You know, we're talking about let's ban gas boilers in new buildings from 2025. What we're going to do is sit and play cards for 4 years. So, you know, we can't even do the easy bit right. So where are we at? We're going backwards. We need to have a blend of carrot and stick. And in terms of the stick, in terms of existing buildings, for me, air quality is the key battleground. It's about obligating existing buildings to reduce their emissions of NOx by divide it easier in Scotland because it's 2045. So 25 years under 100% at day one, which is now 4% reduction in NOx from every building would push people to do something different. And that's the problem. We're happy for folk to keep doing what they're doing, which is turning up and eating donuts at the Weight Watchers meeting. And I probably should be there rather than here, but it's if you keep letting the status quo exist and in fact undermine it, and that comes back to the spark gap. Why has the spark gap risen from 3 to 5.5 in the time period of less than a decade? It's because government policy is actually acting against what we're trying to do. So it's actually a stick bashing the industry on the nose to move backwards rather than prodding it to go forwards. It's really not complicated. If somebody with a magic pen could write it in 2 sides of A4 and the whole thing would absolutely motor and there'd be more jobs and you could shake the stick at. But we're not. We're playing around the edges and just not getting anywhere.
Actually, Dave, if we were just to focus on new build, that would get us on our way. They want to build 300,000 homes a year, put heat pumps in every single one. I've probably just heard a lot of developers just screaming now, you can't do that. You haven't got the people to do it. We can't figure out what heating loads are in our building. And by the way, a good proportion of the buildings that I'm going to put up anyway are old building regulations anyway. So, you know, whenever you look at it, and actually new build is, I don't like using the term low-hanging fruit, but low build is the low-hanging fruit. We should be able to do that virtually straight away. But it's going to take us some time to get it there.
No doubt there's challenges with it, Graham, and I don't say that you just do something and then it happens. You solve the problem and create secondary problems, but you solve them. You know, John mentioned it about making heat pumps easier to deploy. Yeah, there's lots of things we should do to make it easier, but we've been using terminology like low-hanging fruit for at least 12 years, if not longer. Our challenge is not to build every new building with a heat pump in it. Our challenge is to fix all the old ones, and that's the worrying thing, is we're not even off the ground. Even the data, and this is really what government's all about, is data. 2 pieces of data spring to mind. 3. The first is the price of gas is projected to stay cheap for 20 years, right? What signal does that send to the market? The second one, and we're slowly fixing it, and it was mentioned in, I think it was in Matt's stuff, was the grid intensity factor of electricity. It was out of date for 8 years, saying that the electricity grid was twice as dirty as it was. It's nuts. It's completely nuts. That is a stick comatosing the donkey, so it's never going to move. So it just doesn't work. And I suppose the last bit is, you know, the sort of demand profile for heating that we talked about. You know, we need to get a reasonable level of accuracy of what we need to do, as you said in your remarks, but it's not complicated. But we need to go forwards. We're very short out of time. And the only other thing I was going to say in terms of data, any stats around renewable heat in the UK are predominantly biomass, and people have taken all the biomass RHI money, installed biomass boilers, and when their biomass ticket runs out in however many years it is, they'll have a choice of either face a 4-fold increase in the price of their biomass because it's not subsidised anymore, or revert back to a gas boiler. And guess what they'll do? They'll revert back to a gas boiler. Whereas if you install a heat pump, you've got it. You're effectively subsidising the equipment because the operational cost is okay. It's not, You know, talk about the spark gaps and more, but the operational cost is okay. It's the capital cost, but that's not because they're too expensive. It's because they're complicated. Something that magics 3/4 of the energy out of fresh air or out the ground or out the sea or the river, it's going to cost you more money, and rightly so. But the running cost is only about 75%. The running cost is about 75% of a heat pump. So the capital cost is not the place to focus. It's the running cost.
I know Graham wanted to say something in there, but it's ironic that when we're talking about we're running out of time, we have run out of time on this session and barely scratched the surface. And Dave has lobbed another couple of things in to set the question and answers alight. So that will create merry havoc for the next session. So now what I want to do is, in traditional fashion, I know it's hard, but in traditional fashion, can you give us one positive thing to take away? What people can do? What do we need to do next from your perspective? I'll go to Dave first, so that he doesn't finish it off on a pessimistic note.
Yeah,
I'm only teasing you.
No. When I came into this, half the folk had never heard of heat pumps, and the other half had heard they don't work. We now pretty much accept that there's a heat pump for every type of building in the UK, and even industrial processes over 100 degrees, we will see heat pumps being deployed for those. So we've brought them to attention, and we've proven that they work. It's just that the regulation of the policy is undermining it.
Okay, great. Thanks, Dave. Graham?
You asked the question, what can our audience do to help? Actually, we need to get everyone trained to put in heating systems, and I don't care whether that's a boiler or a heat pump, right? If we don't do that, we're actually missing the whole point of this. Heating systems in general, we need to understand their size, we need to reduce the amount of electricity or the amount of energy we're using to run them. So as far as I'm concerned, it's got to be, let's get our installers trained, let's make that mandatory, and let's get the developers on board and make sure they're putting heat pumps into new buildings. At least if we get that far, we've made a start. The rest of it's going to follow on.
In fairness, there's a lot of comments and questions about training in heat pumps and that kind of thing. So this is clearly something to tackle.
And that's where I've spent most of my last 3 months is talking about training and heat pumps. And believe you me, it's a bun fight.
Indeed, Phil Hurley mentioned it at the top of the morning. So we'll move to John. To all you have to do is wrap up this session in a conclusive fashion there, a couple of sentences. Oh, you're on mute, John, so perhaps do it again.
I think just to answer the question, any member of our audience who's approached for advice should start to bang the heat pump drum, really. Whether it be commercially, domestic, an installation level, or an architect or an M&E consultant, we all need to be saying the same thing to move the industry forward. And that's it, I think.
Great stuff. Thank you very much. There's warm recognition for Dave's telling it as it is out in the audience. So there you go. Thank you very much, gentlemen. Plenty of food for thought again. Gives us even more of an invidious task on the wrapping it all up in a minute to try and pull all these threads together. Thank you very much for your contribution. So we're back now to the last session of the day. And we've given it the name Tying It All Together. The beauty of Zoom is that we don't have to end dead on 1 o'clock. So we're going to probably go 6 minutes or so over. We just, as we speak, looking for David Freeze, as we speak, is trying to get back in, allowed back through past the gatekeeper to be allowed in. But I am delighted to welcome Ilias Vasios and Melvin Gums to the panel. I see John's picture's still up there, so we're hoping that he's going to leave this room rather than confuse us. So it's good. We're in the Tying It Together session, and it's good that we have the 2 new members of the panel to talk first, because I know that both of you have certain perspectives on what we can do as an industry to grasp this low carbon challenge. And I know for you, Melville, it's training is a big thing. So we'll go to Melville first, and then I'll throw over to Ilias.
Yeah, training is quite important because with all the new aspects of what's happening in the industry, we need to get proper training for everybody to carry out the potential, make the services more viable and much better for the general public. The thing is that there's a lot of people out there who are not trained properly, and they go out masquerading as plumbers, heating engineers, and all sorts of electricians, all trying to be somebody they're not. And what they're doing is causing a lot of heartache and problems for genuine bona fide installers. And we have to go around and rectify the work they've done. The customer gets double charged. And so you get this thing about customers, oh, he's a plumber, oh, he's an engineer, and oh, it's so expensive, this and that. And it's nothing like that at all, because to be a bona fide installer, it costs you money to get the registration, the training, and your ongoing courses which you attend. You pay out your pocket. So the only way you get it back is through charging a reasonable sum to do a fair job, and that's what we try to do, and that's what the institute is trying to actually get across to members, that you know, to be fully insured and have your services and have your paperwork all behind you, it's going to cost you X number of pounds before you start. Next number of pounds has got to come from the customers and the people you work for. So there's got to be a fair swing back the way things operate.
So what's the, I've done this to all the panelists so far, so that's the challenge, but is there an answer, is there a solution?
Well, the solution is that people should be registered, and that's where we're heading, or we need to be heading that way. We have proper license. Heating is not so bad, but the gas is regulated and that's under control, but the plumbing is not under control. This is where we need to get proper registration done and get bona fide installers and get backing from the government to make sure that a person who comes into your house is properly trained and knows what he's doing. And that's where we need to get to. And that's what causes a lot of problems. And a lot of people suffer from bad plumbing, because we all know plumbing is the essence of life. Now, you can't have a society without decent plumbing. To get decent plumbing, you need decent engineers. To get decent engineers, you need decent training. To get decent training, you need legislation to make sure that these people are trained to carry out the work as they should.
Thank you. Pretty strong message there. So Ilyas, you're coming from a slightly different perspective, but I know that Acuity have done a lot of work on the low carbon landscape. So yeah, where do you see things heading?
Thank you very much, Andrew. Thank you very much for inviting me. And I did follow the whole program, which was very interesting. So I did jot down a few notes reflecting on this of various discussions we've had today. I guess the first reaction is disappointment, because I've been in this sector for 10 years, working on low carbon heat policy and markets, and the initial reaction is not much has changed over the past 10 years. So deployment remains low. So we did hear that we're still installing about 20 to 30,000 installation heat pumps per year. When the objective, as someone said during the course of the discussion, should be 500,000 by 2030. The installer base isn't substantial, so someone talked about a figure around 1,000 MCS registered heat pump installers. So that's nowhere near where we need to be to achieve the mass scale that the government envisages by 2030. And then I think also consumers aren't flocking to buy low carbon technologies like heat pumps. There isn't a consumer buzz around it in the same way, you know, as we experience with Tesla or, you know, electric transport, for instance. So that's an instinctive reaction, is disappointment. However, I think there's a sense that we are on the cusp of change. So there is a reason to be optimistic. So I think for the first time, as someone said, the government is focusing on heat. So heat is at the heart of the decarbonization debate. I think that started with a clean growth strategy, but the green transition is at the heart of the government's, the post-COVID reaction by the government. We've seen the green home grants, for instance. There's a heat strategy coming out by the end of the year, which is going to be very ambitious if the ministers follow through on what they have been saying. So this is a source of optimism. We see even the incumbent heating system manufacturers, everyone is taking low carbon more seriously. We have new heat pump products being launched, manufacturers looking seriously into hydrogen for heat. So there's a lot of activity there. And I think also citizens are becoming more interested. They're keener to understand. We've seen the outcomes of the climate assembly. Over 80% of citizens polled said that they would be willing to buy a low carbon heat technology. So there is source for optimism, I think, as well. We're on the cusp of change. And reflecting on all the, sort of the discussions today, I'd say there are three things that need to happen to capitalize on this good position we are at the moment. I think first and foremost, I think the government needs to follow through. And I believe, as someone said, that because we can't subsidize forever, at some point we need a commitment for change in the building regulations, potentially through tightening emission performance standards, as well as tightening maximum flow temperatures to create kind of some certainty and the path towards decarbonization for heat. The second bit is we need to carry consumers, and I think I'm an optimist here. I think consumers or citizens can change, but as we've seen in other areas, I think the climate assembly showcased that, but we need to explain it to them. Then we need to have commitment, consistency, and authority from the government and the industry to say this is the right thing to do. And I think the final ingredient is installers, because we know that consumers trust installers. They have carried out surveys where we know that installers are the key source of advice for consumers when they make a choice about the next heating system that they buy. And I think the industry has a role and a responsibility there, because there needs to be a mass program of upskilling and retraining installers to install new technologies. And perhaps there is a commercial benefit for industry players that get this right in terms of market share this decade as the market transitions. So I hope that's useful as a reflection. Some sources of disappointment, but some areas where I'm very confident that we can make it happen this decade.
I think ending on an optimistic note is a good sign. So thank you, yes. So David, welcome back. You've made your way through the burdensome administration. We're just trying to fulfill the name of the session, which is tying it all together. But I always knew this was going to be a struggle. We've had so many different elements thrown out today, many of which seem impossible to integrate together without some kind of magic bullet solution. What I'm looking for some optimistic threads from you, David, as to how we can all move together and grasp tie all these challenges together as much as anything else.
Yeah, there are lots of challenges there, but there are also lots of opportunities, aren't there? One of the things I'm really fascinated. I thought they were great presentations today, and several things struck me. One is that there's there are many scenarios where this fits, but it's called turning off the tap and draining the swamp. So while you're putting new build in that you still have an option which is not low carbon, you're continually increasing the level. So you've got to turn the tap off first, deal with new build. The sensible way to do that is legislation. Just get it done, no gas, simple. You've dealt with it. And then you drain the swamp is more complicated and becomes increasingly complicated. I was also struck by the comments, and I've forgotten who made it now, about condensing boilers when they were first introduced, and still to a degree now, not always correctly installed, not as part of a holistic integrated system, but as a box fitted, tick a box, off we go. And the danger is that we'll do lots of heat pumps that way, and we'll do lots of other technologies that way. It's ticked a box. And I think the argument, the specious argument was always, oh, it doesn't matter if it's not in fully condensing all the time. It's still more efficient than a standard boiler, which is nonsense, isn't it? And it's such a wasted opportunity. And I sit in a block of flats at the moment with a massive solar thermal array on the roof that has never worked and can't work because it's incorrectly pipe work, and we're still in dispute to get it to operate. But actually, as far as planning is concerned, as far as the freehold, everybody else is concerned, they've ticked the box. It's got a low carbon solution on the roof. Does it have to work? No, it's ticked the box. So we've got to tie that up somehow. And the third point I took away from it was about the need to revolutionize our thinking on training. It's no good simply saying, here's a course, go and do it, because there's going to be a big market. Because as I think I said at the beginning, your future self doesn't exist. If the market's not there now, why would I invest in that now when I can carry on doing gas boilers for years to come? And the answer is that actually we need to completely revolutionize the way we think and train. During the lockdown, we had the idea in March and have just launched this week BESA Academy, which is a blended learning. So anything that's theoretical, do at your desk, do at home. Don't have to go to a test center or go somewhere to do it. Do it in your own time and in your own convenience, and actually in a way that's kind of gamified, that's actually not a grind, it's fun and you're learning. And then do the practical stuff somewhere close to you that can pop up and just deliver it. So I think if we're going to get the numbers are massive, aren't they? Massive opportunity, 19 million heat pumps by 2050, 1 million by 2030. I mean, staggering. So you have to get people to do it, but you have to incentivize them to do it. And that means change your own mindset. Because I don't think government are going to do that for us. Never, ever. Take leadership and get on and do it.
It's interesting because one of the questions that's come in, more of a comment, is one to throw to Melba, is do you think that all this prospect of change is putting too much on the installer's plate? Is it like, are we facing this prospect of installers not knowing which way to turn, whether they're going to go heat pump, hydrogen, boiler, etc.? You know, what's the view from the guys that are putting the systems in?
But it's a bit like that because each time you have to reskill and retrain in certain applications. So you get training them in putting heat pumps, and then they change, and you've got to go back to boilers, and you can't keep going backs and forwards. You've got to decide which way you're going to go forward in the industry, and we've got to take it from there and take the bull by the horn and go with it, because it's not fair on the installers to keep having to fund the training to learn a new skill, because the manufacturers, they're helping now by putting on the free courses, different types of appliances and heat pumps and boilers and anything that's coming in. They do try to help out, but at the same time, you still have to give up your time to go and train, and that's the problem you will have to face. And guys, they still have to go out to work, still got to earn a living, yet still got to retrain. It's the retraining bit which is a difficult part for us all to grasp and to fit in. You make a sacrifice. You're either going to become part of the system and actually learn everything, or you're not. And that's the choice that people have to face. Either you're going to be part of it or you're not. and we need to have proper training and proper legislation to actually carry these things out.
It's interesting. I'm just thinking about the enormous scale of the challenge and opportunity, depending on which way you look at it. And I'm thinking about the amount of money and the amount of effort that's been thrown at COVID. Some of it not altogether working out right, but I'm thinking about the Nightingale hospitals. Lots of money, lots of intent, things done very quickly and very effectively. And it's almost like we need something of that kind of scale, however we produce that, but that kind of intent when it comes to low carbon heating. It's like, let's get together, do things at pace and at scale.
We're dilly-dallying over it all. You know, we've got heat pumps, we've got hydrogen boilers coming, we've got condensing boilers. We've got to decide what we're going to do. We can't have all these different systems. It's not fair on the installer.
Yeah, we need to get beyond the which is easy for me to say, get beyond the commercial issues and start working together.
The manufacturers only looks after its own base really, but the installer that look after everybody's base. At the end of the day, it's the installer who gives the client or the householder the advice on which way to go. And depending on what incentive he gets from different manufacturers, which will decide on what he uses in the end. And that's what's driving the market.
And I think that's the challenge, isn't it, for the heat pump community really, is that if you don't, if the installer or the contractor doesn't like something or hasn't been infused by it, well, he's not going to fit it or she's not going to fit it. No. So that's where we've got to get to. David, you can tell you're dying to get back in here. You can tell from your body language.
Yeah, well, one of the other things we're not really considered is the age profile of the installer. So, you know, a lot of them are in their 50s who really aren't going to retrain now or no desire to retrain now. So we've got to bring new people in who can do this, who then aren't, polluted to the wrong word, polluted by the mindset, but don't know any other world and therefore will embrace something that's new. But Phil's point about they need to be low carbon installers, they have to understand the whole system. Then it becomes much easier to integrate into something else if you understand how the whole integrated system works, rather than just someone who installs heat pumps. Fine, that's all I do. I just connect up and off I've gone.
Well,
Carol, sorry.
It's not really. It is like that, but if you're getting younger installers in, they still got to be trained in the old ways, because the old ways, as I say, are the best, but so are the new ways. So it's finding the happy medium between the two, and getting the young guys to join the industry for a start. It's a big problem we're all facing. Is the skill shortage. There's not enough skilled people around, and skilled installers and skilled tradesmen to actually carry out the work to the quality which we expect it to be done. And that's the aim of trying to get to that stage, having decent, qualified, well-trained all installers who do things by the book.
But you'd like to think, wouldn't you, Melville, that what a great opportunity for bringing young people and new people in. This is like you are offering them a chance to change the world or save the planet, or whatever green phrase you want to use. You know, there's a lot of these younger people very idealistically driven. What a great opportunity. You can actually help people lower their carbon in their homes and buildings. But it's about how we grasp that opportunity, isn't it?
And how you put it over to them, because at the end of the day, they come into the industry. In a few weeks, they think, "Oh, it's just not for me."
Yeah.
When they go.
So it's back to what David was saying about we need to have a radical rethink about the whole training opportunity, because if you haven't got skilled installers and contractors, you haven't got.
It should start at schools, really. They should start the training at the low levels in the school. So when they get to going from school into a work environment, they've got some idea of how their house operates. You know, you ask any youngsters, they turn a tap on, water comes out the tap. They know, they don't know how the water arrives there and then what the quality of the water is. Same thing, they flick a switch and the heating comes on, but they don't know how it actually operates. And this should be taught at the school levels so that when they get 17, 18, they start getting some idea and they start getting feedback of what it's like to actually become a qualified plumber, heating engineer.
It's interesting actually, because we just had a comment from the floor which says if we do that, we need to tell the kids at schools that it's not just about boilers and showers, it's about that low carbon opportunity. And try and look, it's, you know, the words that keep coming across is very easy to say: collaboration, working across disciplines, integration. You know, we heard a lot today about how for heat pumps to embed, you need to work closely with the electricity providers and that kind of thing. It is about looking things in a new way, and we can't be siloed in our thinking. Right, it's come to that point, gentlemen, where we've got to do that try and wrap up the session with a sentence of what we can take away. But you have an even harder job, because I want you to give people something to take away from the day. So I'll go to Melville first. I imagine you're going to say it's training, but you might not.
Well, it is training, because that's the only way we're going to go forward with all this is proper legalised training in a decent training school where they get taught how to do the job correctly. Also to join a proper certified body, proper institute to look after the training and to make sure that the work is done properly. CIPHE, we sponsor, not sponsor, but we are affiliated with certain colleges, and then we try to get the trainees and the youngsters to join the institute, and then they get onto the band of doing things a professional way, and that's what the game is all about. That's a nice circular conclusion on that note, because that competence is what David mentioned at the top of that morning. So Ilias, to you.
I think for radical change to happen this decade, we need we need installers to invest their time and efforts in upskilling. We need the industry to invest in innovation and launching new products. And I suppose bringing it back to an area which I like a lot, and it's an area of expertise. For this to happen, these actors need to see a growing market, and this requires policy. So I think it's up to policymakers, assuming anyone is hearing us at the moment, to deliver, perhaps in the form of tightening regulations. And I think many people are expecting to see something along these lines in the upcoming heat strategy by the end of the year.
Yes, let's hope it comes out by the end of the year. David.
I'm going to kick off by saying actually forget schools. I think actually way below teaching them how the heating system works, they'll be actually teach them how to feed themselves and how to look after their finances probably come way before that. And there's not much chance of that getting on the school curriculum at the moment. And in fact, forget about help from pretty much anywhere. Government might help, but it's that consistency of help is the bit that David's, why can't it be consistent? And it's never going to be consistent. It's going to be a tap that turns on and off throughout the period. I would say actually you probably know more than you think you know, and you're probably much closer to being able to do this than you think you are, and are probably a bit afraid of having a go. But actually, you wouldn't have got to where you've got to unless you have a degree of competence. So have faith in yourself and go for it. Choose a technology that you think is going to work with heat pumps, or if you're willing to wait till the hydrogen network is up and running, go for that. But actually commit to it. Do the training, CPD, invest in yourself. And now, during lockdown, some of the biggest businesses in the world during recessions are built. Now's the time to go for it, because nobody's going to do it for you. There's a final bit of history, Stoicism. Stoicism is a philosophy from ancient Greece that says there's absolutely nothing you can do to change the things around you. You can't do anything about COVID. You can't do anything about the climate crisis individually. It's only how you react to it. And the way you can react to it is to engage and get involved and get stuff done. Otherwise, nothing will happen.
It's a call to arms to end. Call to arms to end with. Thank you very much, gentlemen. That's great to, we try and pull the threads out of what's been a very intense morning. With this summit, we decided that we try and focus in on one subject over 2 different mornings to try and allow more time. It still seems like we haven't got enough time to get into all this. We've thrown up a lot of ideas. There's a lot to be thinking about. I would summarize that collaboration is key. It's also that it's a great opportunity, and that there may be installers and contractors out there that hadn't thought that low carbon is a very immediate thing to get involved in, but clearly it is. If you hear those numbers about reducing in time for net zero and before, there's clearly, moving at pace also includes investing in technology and selling it. So, yeah, you're right. There is grounds for optimism, but there's also a lot of talk that needs to be done. Some of you representative associations, I think we're relying on you to get some of those policy makers in a corner and tell them what for. But there's, let's end on a high note. There's plenty of opportunity, but it does depend on collaboration amongst the disciplines. And we always, on HMV, it's very simple for us to say it's hydrogen versus heat pumps. It shouldn't be. It should be hydrogen and heat pumps, or low carbon methods. Full stop. So I will allow you gentlemen to turn off your videos now. So I'm just facing the screen for the final wrap up. Thank you all in the audience for listening to this. It's been really interesting. If you feel you didn't have your questions completely answered, do feel free to email into us. Thanks to the sponsors for our summit program, who are Residio, Swagon, who you'll hear from next week, and of course Kenta Contracting. And on that point, on next week, so let's remember, next week is devoted to indoor air quality and ventilation in the post-COVID world, or the current COVID world, as it should be. There's the program. It's going to be interesting, but it's only interactive if you join in. So you'll already be registered for both if you're watching us now, but do tell your friends and colleagues, because it's going to be another interesting session. Thanks very much to everybody involved. Thanks to organising colleagues. Keep watching HMV online as we keep writing about all this low carbon stuff. And if you've got things that we don't feel we're talking about, let us know. So it remains for me to say thank you very much. After 4 panel sessions, I'm off for a gin and tonic, I think. Thanks very much and goodbye.